Go live. Hello everyone, and welcome to the Gravity Max live stream. Today is the finale of Season 1. Of course, we will be having a bonus episode next week. That's not going to be very science related, but that's why it's a bonus episode. So, yeah, let's get started, right? Okay.
Yeah, let's do it. So I'm here as always, and
Nice.
I'm excited as always.
Great. It's going to be a fun stream.
Yeah.
Yeah, today we're looking at the monster equation. Of course, very lightly, I'd say. It is such a expansive topic. It's kind of beyond.
It really is.
I think it would take an entire semester college course to fully understand it. But we're just gonna, define some variables and whatnot, just typical stuff, right? So we're also going to be having a fun little game show format, and we'll explain that in a second. So, yeah. This video is not intended for children under 13 years old. If you are under 13 years old, please do not watch this video, as the topics we discuss are meant for those with at least a high school level of education. If you are not 13, you will not understand the scientific topics discussed in this video. And of course, that's just the typical disclaimer. That is just our FTC covering all bases, So, yeah. I mean, we're talking about quantum physics, so I would hope that they wouldn't come at us with some fallacious claims, but yeah, you can never be too safe. So then follow us on social media and visit the Gravity Max website. Follow Sebastian on social media at Carl Martin.
Still got that one post. One post only.
I love that post. What a good post. So then
It is really just a work of modern art.
Yeah, modern Renaissance painting. And then it's blurry a little bit too, but you know exactly what's going on. It's great. So then Truly Dead Rock, available in the description, sci-fi book. If you like sci-fi, then you should get the book. If you don't like sci-fi, then what are you watching? I will not tolerate any sci-fi haters here. But yeah, it's a fun book. So, yeah.
It is. It's a good book.
Yeah, I've already sold 20 copies, I think.
Ooh, nice.
Let's see, 20 times 5. No, actually, it's probably closer to 30 or 40. So, yeah. Getting those royalties. So, yeah. Anyways, so the monster equation.
We've been hinting at this one for We've been touching upon it. I think we've talked about it in 3 different episodes. I want to say 3 previous ones.
Yeah, we talked about it during the periodic table episode. Or wait, was that the quantum mechanics? Or I think it was periodic table. Or it was quantum mechanics. I'm not sure. It was one of them.
It was one of them.
That was when
that's where we found it. And then we started joking about it. And now we're here.
Yeah, last week we did it for an hour. But what did we tangent on instead of doing it? I forgot. We did something.
Yeah, I don't remember.
Airplanes was the time zone one. Airports and stuff.
Airports.
For those unawares, we have a 12-hour live stream last week. That was an all-nighter. Not going to do that again.
It was fun.
It
was fun, but never again.
Not going to. Not unless I get a ridiculous subscriber count in a ridiculously short amount of time. But yeah, it was not. I mean, I feel like that's what we expected, but by the end, my throat was dying just talking and talking. I've found my limit. I cannot talk for 12 hours straight. So, yeah. You can still watch that VOD, although it's not very educational. I'm not sure what you'd gain from it, but yeah. Anyways, so let's move on to this is the equation.
So here it is, the monstrous equation
in all
itself.
Its glory.
This is the Lagrangian form, the Lagrangian expression of the Standard Model. And the Standard Model, we've shown it in a ton of our streams. So if you don't know what it looks like by now, you should get checked for Alzheimer's, like, honestly. But
Out of luck,
basically,
yeah.
the standard model outlines all the elementary particles, going from the leptons to the bosons to the fermions, and then the Higgs, which is also a boson. But the Higgs is weird. But anywho, this is how it can be expressed, not with pretty little pictures, but with numbers.
Yeah. Isn't this just much more convenient? I feel like it just... I think
I get... Like, for me, it's just, like, so I need to, like, look at things real quick. Like, when I look at the standard model, like, lots of colors all over the place, kind of messes with my eyes. This monotone, great, quick, simple,
it's great,
easy,
so simple.
Easy to understand.
I instantly... perfectly understand the universe whenever I just glance at this equation. And then the table, what does it even say? It's too basic, too simple.
Yeah, I don't get it.
It's
like, and I'm willing to admit it. I don't get it.
Yeah.
But this just makes it easier for me as a learner, as a student, and as a global citizen. This is just like what I need. It's what I require, even.
Yep. This should be a country's flag. Just you see that waving in the distance and you're like, oh no.
Yep.
Anyways, so now let's get to the game show.
Yeah, so we're doing this a little differently than any other stream.
Yeah.
Like any other stream ever done, even. So basically, let me tell you how the game works.
Yeah.
So I'm going to ask Max series of trivia in each of these categories, and Max is going to ask me a series of trivia in all these categories. The 6 categories change for both of us because
they're mostly the same.
other person knows nothing about that other topic. But basically what's going to happen is that we have a scoreboard, which we'll show you in a moment. If you answer the question right, the trivia question correctly, you get that amount of money that goes into your balance. If you answer the question wrong, you don't get any money, and you need to define a variable that we haven't already defined from the Lagrangian Standard Model.
Yep.
Whoever has the bigger balance at the end is the winner and gets bragging rights.
Yep.
And gets to be the official certified big brain.
Yeah. Let's take a look at this scoreboard.
Let's take a look at the scoreboard. Both Max and I have graphic design knowledge, which we threw out the window when we were creating this.
Yeah, pretty much. So we've got the fractal on the right, and you've got that foreboding hand in the bottom right.
The foreboding hand.
There's always a bigger fish, as Qui-Gon Jinn liked to say. And then Sebastian, he's just phasing in. He's sliding.
I'm sliding.
That's a joke you'll get next week. That's a joke from the future. He's sliding.
That is a joke from the future.
Yeah, shout out if you're watching a week from now. Shout out if you're watching in 2020. You'll understand the joke. So let's see. If you're
a week from now is not 2020. Sorry,
well, a week from now or 2020. A week from now
or
that's kind of what I meant. That's what I meant.
Yeah.
So, yeah, let's get on with it. Should I ask you a question first, or do you want to ask me a question first?
You know what? Lob the first one at me, Max. So just for clarification's sake, the board that says Sebastian is the questions that I'm going to be answering. The board that says Max is the one that Max is going to be answering.
Yep. All right.
So I'll take the first question, and I'll take astronomy for 200, please.
Nice. Okay, astronomy.
And I can't Google anything. I have.
Yep. Okay. Let me
in front of me, all I have is my desk, and that's it.
Yeah. Let me pull up my questions. Okay. Astronomy for 200. So, what proportionality does the strength of gravity follow? I might have phrased that weirdly. So, if you move x times further away from an object, by what factor will its gravitational pull change?
That's the 200 question?
Yeah, it's a pretty simple. It's the law of gravitation. It's the blank blank law.
Okay, what factor will it change?
Yeah. So you move x times away. In terms of x.
I'm already getting ashamed. Alright, okay. So I know Earth's gravity. And I know damn well, no matter how high I jump,
Mm-hmm.
On my trampoline,
Mm-hmm.
Earth's gravity stays the same.
Okay.
I know that in Denver,
Mm.
Denver's is the mile-high city.
Yep.
But gravity's still the same.
Yeah.
So, using this knowledge,
Mm-hmm.
I'm going to say that the factor is...
Oh, no. Wait. Wait. I'm going to give you another hint. Think of the equation for gravitational force. Do you know that equation?
Of course.
The gravitational constant times mass 1 times mass 2 divided by a certain value.
Of course.
You know that? Yes or no?
No.
Okay.
Wow.
Okay. Let's see.
No. I'm gonna get it. I'm gonna get it.
Okay.
If right now, it's the temperature outside is 29 degrees Fahrenheit.
Okay.
Knowing this,
that is freezing, dude. That's crazy.
Knowing this, I can conclude that the factor is 0.75.
It's a tragedy. It is a tragedy. It is 1 over x squared. It's the inverse square law.
What the hell?
You don't know the inverse square law? Okay. Maybe that was too complicated.
I do know a lot about astronomy. Don't give. That is just not one of my knowledge. Not part of my knowledge. All right, on to the equation.
Yeah. Which variable?
So far, what did we define up to? We defined up to we got Z and W.
Mm-hmm.
So then we keep going. I don't think we did A. Did we do A
what's
yet?
A? What's A? Tell me what A is.
Now I'm going to show you my process. Okay. So I'm going to do common physics notations. And then I'm going to cross-reference that with the context of the model.
Okay.
So, A can stand for area.
It's area.
It's area. No, A can stand for amplitude, which is the amplitude of a periodic variable, which is the measure of its change over a single period. So, there's all that. Or simply atomic mass number. So, I'm going to go, it stands for amplitude for this one.
All right. Fair enough. So then I guess it's my turn. I'm not sure. Are there even like 60 variables on here? There's gotta be.
If there isn't, then we're gonna have to like explain. We're gonna have to go more in depth to it. So
it's just until the other person is
satisfied
with it. Yeah.
Like the worse it gets.
Okay. I see.
Okay, so I've defined up to A.
Okay, so it's my turn now.
And I have a balance of $0. Why did I start? Okay. Max, what do you want?
I'm gonna start with. Let's see. Let's start with particles for 200.
Particles for 200. Good choice. You're going to move it?
Yep.
Okay.
There we go.
Particles for 200. Yeah, see, I made my 200...
Easy? No, okay. All the other topics for 200 are a lot easier.
Okay.
That's probably the hardest 200. But I thought it was simple, like 1 over x squared.
Yeah, bad luck. It was either I knew it or I didn't, and I did it, and that's fine.
Yep.
Because you know what I just did? I learned.
You learned, exactly.
I learned.
And so did the audience if they didn't know.
The audience learned too. Audience, did you know that? Okay, yeah, that's what I thought.
Wait, let's check the chat. Okay, there's some chat. Audience, did you learn? Okay, so let's see. Missing Music says, but what if I'm mentally 5? Can I still watch the stream? I think that's a bit of a gray area, but just so the FTC isn't mad, I'm going to say no. So grow up mentally, okay? And then we slide in into the DMs, says Missing Music. Sebastian, about to answer Max, oh no. Max, let me give you another hint. That is too accurate. You have called us out.
All right. So your question, particles.
Mm-hmm.
Right, or it was particles, not physics. Yeah, particles for 200.
Mm-hmm.
Maxwell Riley-Rudin.
Mm-hmm.
What is the lightest particle in the universe?
Ooh, that is the electron neutrino.
It is.
Yay.
Round of applause. The electron.
Yeah. Nice job. Oh, Missing Music says, I did not, but now I do.
Look
Exactly.
at that. Look at that.
The results speak for themselves.
They do. They just do.
So, yeah. So that's fun. I get $200.
So,
Let me go and change
$200 to Max. You gonna move the balance or should I?
I'll change it.
Okay.
Oh, okay. You got it, I guess.
Yeah, you can be designated changer of things.
Changer of things. Okay, cool. Okay,
all right.
So now let's see. So what do you want?
You know what? I'm gonna shift topic.
Okay.
To back off, let the coals cool, as they say.
Yep.
I'm going to take chemistry for 200, Max.
Alrighty. Chemistry for 200. Let me pull up my chemistry question. Okay, chemistry for 200. Okay, how many valence electrons does chlorine have?
1.
What? How?
Wait, no, not 1. Not 1. No, 1 is what it needs. So it has, it has 17. Right?
No.
No?
Valence electrons. It does have 17 electrons.
Valence. It's got chlorine, -1. I'm not looking at a periodic table.
Yeah.
Because that's the rule for this. You can't have any. So I'm like closing my eyes, like viewing it in my brain. Yeah, so it needs 1 for a full shell. Has 17. It's in that. God, what's its electron configuration? 1s2, 2s2, and then you got the it's got 5?
No.
5 valence electrons?
No.
No?
No.
Oh my god. What does it have?
It's 7.
How many?
7.
What?
Like the octet rule. You know the octet rule?
Oh, okay.
If it's missing 1, it needs
fine,
7.
Fine. Okay. I know a lot about
It
chemistry.
has 7. Okay.
I know a lot about chemistry. That messed with me because I don't have a periodic table in front of me. In real life, you will always have a periodic table in front of you.
That's true. You got to remember the enes, though. That's how I remember the halogens. Yeah. They're all enes. Anyways, define something.
Oh my god. Okay. All right, here we go. What have I not defined? All right, we keep going. G is just gluon. We keep going. C?
Capital C?
Have we defined C? We've had sub C. So we said it had to be part of some sort of system, right?
Yeah.
Okay, so we keep going.
No, I think it's charm though, right? Because C is like on its own, it's probably charm.
Is that what we said last time? Because we've hit C before.
I think we did.
Okay.
So just, I guess, say something else.
Although it says C sub W, and I'm just wondering if that's the same W as that, because that's a lowercase W.
So it would be charm quark. What property of a charm quark? Look up W.
Yeah, let me see. W is for width, like that specific. So
I don't think it's width. They would use something more elegant, like radius.
Yes. True.
Not as
well. This equation isn't exactly elegant.
Okay. Well, have you read The Elegant Universe?
I have read The Elegant Universe.
Do you think that's more elegant? I mean, kind of, yeah.
Well, what if it's talking about the width of a?
I don't think it. Dude, only like math problems use width, not particle physics. They use radius. So,
are we gonna say that that's the same W as that? Because that same W was the capital W was mechanical work.
No, what the capital W was the W boson.
Oh wait, no, you're right. It is the W boson. It can also be expressed as mechanical work.
Yeah, but just in this situation. Okay, let's see. The lowercase w, just look up what does lowercase w mean. Is that the only meaning?
Yeah, that is the only listed thing.
Well, it's got to be something else. I feel like I remember
wait, what if that isn't a W and that's actually omega?
Yeah, see if it's omega.
Okay, if it's omega, then that could be, it's definitely not ohms.
Mm-hmm.
It could be angular frequency, which is a scalar measure of rotation rate. So maybe that's talking about the spin. Spin of the charm quark?
Yeah, probably. That could be it.
Okay. I'm going to take that.
Yeah.
These are honestly just getting harder and harder as we go down.
Honestly.
Because they just get more and more diluted.
Yeah. Oh my god.
All right, Max. Your next question.
Mm-hmm.
And my balance is...
Yeah, your balance is still 0.
Yeah.
Okay, let's see.
Hurts.
Let's pick physics for 200.
He's going to take physics for 200.
Yes, sirree. Bam.
What is Newton's second law?
Okay, Newton's second law is F equals ma.
That is correct.
Nice. Bringing in the dollars. 200 more. Bam. I'm 2 for 2, you know? Hopefully this rides. Hopefully I didn't just jinx myself.
I'm 0 for 2.
Yeah.
I'm not doing well.
Okay, so now, what is your next topic?
All right. I struck out in astronomy. I struck out in chemistry. Let me go to biology. Maybe I'll do better in biology. Biology for 200, Max.
All right, I will.
Oh, and by the way, for anyone watching, we have to go in order. We need to go 200, 400.
Yeah, because it's not like the actual game show where we're competing on the same board, so it doesn't matter. And it makes it way more climactic if you do it in order like this. So for any given topic, you can't do 400 of a topic before you do 200. Yeah. Okay, so biology. Oh, this is easy.
Biology for 200. Okay.
Define biodiversity. And that one goes to Yui Films.
Biodiversity is... I'm not going to get it verbatim.
Yeah, that's fine. That's fine.
It is a range of different species and flora and fauna in one specific ecosystem or environment.
Yeah. Nice job. So I will add to thine balance.
We be getting money. You can't step to me.
Nice job. Okay. So now, let's see. Now, what do you pick? Or wait, you just went. Sorry.
It's you.
Yeah, sorry. I'm going to do astronomy for 200.
Astronomy for 200. This is my topic. This is yours.
Yeah. Let's see.
Now, Max, I'm going to level with you, man. I made these astronomy a teeny bit harder than the other ones because I knew you were so good at this.
Oh, no.
So, this is a detail you should
Okay.
Considering you wrote a book
okay.
revolving around this structure or this heavenly body.
Okay.
What is the gravity of the moon in meters per second squared?
Oh, in meters per second. Let's see. It's probably around 1.6 meters per second squared.
I'll give it to you. That's close enough. It is 1.625 meters per second squared. Yeah. That's pretty good.
Sorry,
round of applause.
Things in my book, I guess, were falling to the ground a fraction of a second slower than in reality. Yeah. Oops. But yeah, 1.6. I know that. It's 1/6 of the Earth's gravity, approximately. So, back over to you, Sebastian. What will you pick?
All right. So, you know what? I'm going to go biology.
Nice. Biology 400. He's on a roll.
Our first 400 of the game.
Of the night. Yeah. All right. Let me pull up my biology 400. Okay. So, what is an autotroph?
Okay. Let's hey.
Yeah.
Auto.
Mm-hmm.
Like AUTO, not the name.
Yep. Auto, like
Auto.
automatic.
Like automatic.
Yeah.
It means that like some self
Mm-hmm.
is able to do it. It means that the organism we're talking about is able to do something.
Mm-hmm.
Now, troph. What is troph? I've heard it before. Autotroph. I'm gonna go something that an organism that doesn't require food. It makes its own energy source.
Yep. That is it. It makes
That's
its own
it?
food.
Oh
yeah.
my god, let's go.
So these
That's
would be
what I thought it
plants,
was.
producers. Nice job.
Oh, I knew I had heard
So,
the name
let's see.
before. Ooh.
You get 400. Oh, wait, did I add 400 to my... Or wait. You get 400. I think I forgot to add the last one to mine.
Do you want to do it just
6.
the person that asks the
Okay.
question changes the other person's?
No,
Just so
it's
we keep
fine.
track
I'll
of it, or-
remember next time.
All right, you're on it.
Okay,
All right.
so now it's my turn. What do
Wait,
I pick?
shouldn't
Oh.
I be at 600? Because that one was a 400?
Oh, sorry. Yeah, 600. Bam. Okay.
All right.
Okay.
It is 600 to 600.
Nice. It's on, you know?
I'm actually very surprised I got that. And I
Yeah?
swear to everyone, nothing Googled. You did not. My keyboard is loud as
Yeah.
hell. You would have heard
It's
it
super
going.
clackety. Yeah.
You would have
Okay.
heard the clickety clackety.
Yeah. Okay, I'm gonna do...
All right.
I'm gonna pick lightsaber colors.
Oh, he's venturing into. category-
And by the
Special
way,
one.
there will not be any spoilers for the new Star Wars tonight.
No spoilers.
Just
There will be
yeah.
probably be spoilers for the original 6.
Yeah.
But if you haven't seen those, you
Where
need
have
to
you
get
been?
off the Gravity Max live stream because you are under
Honestly.
13 years old.
Yeah, exactly. Where have you been since 1977? Honestly, that's my question.
Like, come on,
Oh,
George
let's see.
Lucas
We've got
is
more
disappointed.
chat. So we've got. Let's see. Max is now designated changer of things. What a title! And then she says, "Hey, I know this one. I know what an autotroph is." And then clapping when you got it. So nice job.
Yeah, if you can break down the etymology,
Yeah,
word,
exactly. Etymology is key.
You can get the definition.
Yeah, that's the way to
Okay.
go.
You are going to take lightsaber questions for 200. You see, I'm lobbing a softball at you.
Okay.
Who is the most famous wielder of a purple lightsaber?
Mace Windu.
Mace Windu.
Yup.
What is Mace Windu's middle name?
Oh,
I'm joking.
Okay.
I'm joking.
L.
L.
Oh my god.
What does the L in Samuel L. stand for? I think it stands for Leslie.
Okay, cool. Yeah. I feel like I'm not going to get the higher ones, and then I'm going to get...
Oh, it's
a billions-
Leroy. It's
Oh,
Leroy.
I feel like I'm not going to get the higher ones, and then Star Wars fans are going to be like, how dare you? I'm going to be like, please stop. Do not attack me. I just know the basic colors, you know? Okay, so...
All right.
let's see.
You got to change your
Oh,
balance.
yes. Okay, I changed mine to 800.
800.
Okay, and then it's your turn.
All right.
All right.
I'm gonna go. I'm so scared.
Mhm.
But I feel like if I let them pile up into the end, I'm gonna fall like flat on my
Uh-huh.
face.
Uh-huh.
So I'll take astrology for 200.
Astrology for 200. Not to be confused with astronomy, which is pretty funny. Because he typed in astrology first
Yeah,
instead
I
of
had
astronomy,
it on my
and then I'm
mind.
like, put them both. Okay, so your astrology question. Approximately what % of Americans believe in astrology?
Sweet God.
Now, look, I'll give you plus or minus 10%, okay?
Plus or minus 10%. Okay,
Yeah,
so
if you guess it within...
percent of
yeah.
Americans.
Yeah,
Of Americans?
Yep,
Like
Americans.
any age.
Any age Americans, just all Americans.
Any age, any age Americans. Okay, it is most prominent with like teenage girls.
Okay.
I know that. Most prominent with teenage girls. So, restate the question one more time for me
Okay.
because I want to see how it's specifically worded.
Okay, I said approximately what percentage of Americans believe in astrology?
Of Americans. Okay,
Mhm.
so
I don't mean like
this is where.
I mean U.S. Like I don't mean the Americas.
Okay.
I just mean Americans. Like
Okay, so there is the Western astrology and like the because I have astrology knowledge. I just know that there's a Western astrology and there's Eastern astrology. So a lot of Asian Americans would believe in the Eastern astrology.
Oh.
So that would raise the percentage a little bit more. So teenagers don't account for the largest portion of the population, I want to say. So I'm gonna say that is a believe in astrology. I'm just gonna go middle of the road, 50%.
Oof. It is 31%.
31%.
There is hope yet. Anyways, so
looks
you
like
didn't
I
fall
define...
within the 41%, you know.
Oh.
So okay. So let's see. What do we define now?
Okay, we just defined little w. So we keep moving, we hit new, so that's a new one. Is that alpha? I think that is alpha. Okay.
Yeah, we got alpha.
Okay, alpha. I don't think we've done that before.
Oh, Missing Music says astrology is not astronomy. Thank you, Missing Music. I very much agree. I was at a store, right? And so I started an astronomy club at my school. And so like, I don't know, my mom was like talking to the person there. And so she was like, "Oh, maybe I'll have my son go to your astrology club." And I'm like,
"Oh."
I'm just standing there like you know, in the Joker movie when his boss is saying like, "Why'd you steal the sign?" I'm just standing there smiling like, "Yep, astrology club." And I'm like,
that you danced all the way down the stairs to...
I'm like, I was not pleased.
Okay, alpha. Yeah. Let's look at alpha's position. So where we see it, and I totally lost my place. Okay, there it is. Alpha stands alone, and it is sub H, which we also I don't think we've defined.
I don't think
that yet. So let's focus on what alpha. Alpha can stand for alpha particle, or alpha ray, or alpha radiation. It can stand for angular acceleration, which is the time rate of change in angular velocity.
That is the weirdest thing. I love angular acceleration.
Yeah, and I think that was the we just talked about little w was angular frequency. So we might see a connection there. And the last thing is the fine structure constant, also known as Sommerfield's constant. Fundamental physical constant characterizing the strength of electromagnetic interaction between elementary charged particles.
Oh, it's probably that.
Yeah, I would say it is. Yeah. The only doubt in my mind is the last thing was that angular frequency.
Well, here's the thing. It's interesting. Yeah, I like how alpha particles are too big here. This is the level we're working on. Alpha particle too big to be considered.
Yeah.
Possible. Which is just funny.
So this specific section, what is this section to? Like overall, it's the W and Z bosons. So W and Z bosons carry the strong force.
Oh no, they carry the weak force.
No, the weak force. That's what I meant. Yeah, the weak force. They're weak just like their force. Badoom ching. So they. Yeah, so would they be talking about electromagnetism?
They are charged. You see all the W's have a plus or a minus on them?
Yeah, those are the two W bosons.
Yeah. So maybe it could be about their charge.
Yeah. Okay. Yeah. So, all right, I'm willing to go with that.
All right.
All right, Max, it is
my turn.
It's your question.
Also, Missing Music says, let's see. Dude, I was thinking 30%. Nice job. And then we've got, wow, that lady really said that. Yes, she did.
That lady is mother.
No. It was someone that my mother talked to.
Oh, someone that your mom taught. I thought it was your...
No. My mom's not an astrology person.
All right, don't worry. Thank the Lord. Okay, so...
Okay, let's see. The scoreboard's correct, right? I didn't miss anything? Yeah. Okay.
Yes, you have gotten 4 $200 questions. Okay. I have missed a lot.
Okay,
and I'm currently at 600. I'm two for 5.
Here's what I'll do.
Oh.
I'll change all the wrong ones to white and leave the black ones.
Oh, so you can see my shame.
Yeah. No. So that if we like lose track,
Okay.
that's if we lose track, we can be like, okay. Anyways, so let's see. What should I pick? I'm going to use Physics 400.
Physics 400.
Yeah, just to spice things up. Play a little more.
All right. It doesn't get
risky.
that spicy.
Okay.
You know,
it's picante.
It's not
right?
that spicy.
It's pico de gallo.
So out of the 4 forces, which one is the weakest?
The weakest is gravity by a factor of like 1,000,000 or something.
There you go. It is
Nice.
Gravity.
All right.
Just like the name of this live stream.
Yeah, Gravity Max is really just it's a weak.
It's
No,
just-
this is
it's
fun.
just
This is
weak.
fun. We got to do this
Yeah.
more. We got to do game show style stuff. Next week's gonna be fun. It's not gonna be game show, but it's gonna be a different type of game. But it's gonna be a board game, but an online version, of course. But it's gonna be fun. So, what do you choose now? What do you?
Right now, I'm just fact checking
Oh,
something. I'm making sure that I have a fact correct.
alrighty then. We will. I'll wait. I guess. Yeah.
Sorry.
No, it's fine. It's fine. But yeah, next week's gonna be fun. Okay, so we're gonna be playing Monopoly, but it's this online knockoff version of Monopoly, and it's so hilarious. We've played around between ourselves and a few bots, and it's just so great.
It's so good.
It's so good. As in, it's so bad, but it's so bad it's good. It's like the movie The Room. It's just hilarious.
Oh, hi, Mark.
Yeah, it's like, let's see. So
All right, I just fact checked it, made sure I had it right. It is right.
Nice. Okay.
Let's
so
go.
what?
All right,
topic?
your
What-
serve, and I'm there at the net. I'm gonna go. You see, I in the beginning of this, I was humiliated in astronomy. Let's go back to astronomy.
Returning with a
$400.
vengeance. Okay.
Maximus.
Okay. So, let me see.
You have double my score.
Okay. I think I'm gonna need to rephrase this one. Okay. So
All right.
this is
Best
okay.
kind of
Okay,
question.
okay.
One
So-
that started off incorrect.
Okay. So this is Kepler's first law of planetary motion. Okay. Just like fill in the
Oh,
blanks, please.
sweet. Jeez.
Okay. Don't worry. Don't worry.
Okay, let's go.
So
Let's go.
So this is really just planets orbit the sun in what type of shape and where inside of that shape is the sun. That's the question,
Okay.
I guess.
That's the question.
Yes, because the
Alright,
question was
so-
what's Kepler's first law of planetary motion? And I just gave you a nice little framework of the important
Alright.
bits.
So here we go.
Mhm.
Everything is moving,
Yes.
ladies and gentlemen. Everything is moving. The solar system is moving at like 10,000 miles per hour.
Something
I don't know,
like
but
that.
we're hurtling through space at a ridiculous amount. So when you look at, they all look just like ovals, but you see that's actually not the case because everything is moving. So planets move in a spiral through
Okay.
the galaxy, spiraling
You don't need to consider
all
that
the
level.
way through.
Just consider a static solar system. Just consider the Earth and the Sun. That's it. Just clear your mind and just think of the
Okay.
Earth and the Sun.
I thought you were gonna be like the smart ass or like,
No,
well,
no,
you
no.
see everything's
Yeah,
big,
everything's like.
okay. Well then, yeah. So an Earth's or basically just an oval with
Mhm.
the sun at the middle of that oval.
So, what is the sciencey word for an oval?
An ellipse.
Yes. And what is the sciencey word for the two centers of the ellipse?
Oh shit. Oh no.
Have you done conic sections? I think that's algebra 2, right? Yeah.
Hold on. Oh my god, I haven't thought about this in a bit.
Mm-hmm.
No, I can remember it. The two centers of an ellipse. Okay, so using my from the little
Mm-hmm.
I remember from that unit.
Mm-hmm.
Okay, so hold on. Oh my god, I really have no idea.
Okay, I'm just gonna give it to you. So
Okay.
it's So it is. Let's see. So the Kepler's first law of planetary motion is that planets.
Oh, it's the focus, right?
Yes.
Is that it?
Yes. Nice job.
Yes, that is it. Okay.
So yeah.
Okay, I remember.
Yeah, planets
Sorry,
orbit.
I remember that the last second.
Nice job. Planets orbit the sun in elliptical patterns with the sun at one of the foci of the ellipse. So yeah.
Yeah.
That's the first law. So you get 400.
There we go.
Now you're at $1,000. How does it feel to be a 1,000-aire?
I feel like I have doubled the actual money in my bank account.
Oh my gosh! And of course, these are graviton bucks. These are not. This is not real money.
Which is equal to 1 trillion.
Yeah, it's Zimbabwe. Oh my gosh!
All right.
So yeah, now I pick some.
Your question. Let's go.
I'm gonna pick chemistry for 200.
Oh, chemistry for 200. Great choice, sir. I was about to recommend the same question.
Oh, thank you.
30 to 45 minutes. That's a joke. I have it ready for you right now. This is a pretty easy one, as it is. But clearly someone didn't get the memo.
Okay, I thought you said to make them pretty niche, okay?
Yeah, I did say.
You were like, make them really niche so that we don't overlap. And I'm like, all right.
What 2 elements are liquid at room temperature?
Okay, that is bromine and mercury.
Yep. That is correct.
Yay. Okay. So that is 1,400. Bromine. Bromine's a fun one. It's like red and stuff. It's pretty cool. Okay, so now it's your go. What topic do you choose?
I'm going to take chemistry for 400.
All right. Chemistry for 400. Let me pull up chemistry for 400. Okay. So, what is stoichiometry?
Wait, go. You cut out. What did you say?
What is stoichiometry?
Can I phone a friend? Okay, all right.
This has been a unit for like the past month for me in chemistry, and you're taking chemistry, right? Maybe they do it differently.
You're going to an actual high school. I'm going to just a joke of a high school.
Well, they're both chemistry honors, so I just figured that anyways, so
we have not covered
stoichiometry
it yet, but okay, stoichiometry. Look, stoic. Stoic sounds kind of like steak.
Okay.
Steak. Steak is food.
Mm-hmm.
Steak is specifically food from cow.
Mm-hmm.
Stoic. It kind of sounds like saying steak with a really heavy Boston accent.
Stoic. Okay.
Boston. Food from Boston. Food from Boston is terrible. Terrible. Bad. Bad rhymes with sad. I'm sad. Okay, stoichiometry is the measure of energy of. Hit me with it.
No. Okay, so it is.
No.
Stoichiometry is the comparison of the relative number of moles of the reactants and the products.
Oh yeah, we've obviously hit on moles, but now we're just like.
So it's stoichiometry is basically saying in the combustion of hydrogen gas, 2 moles of hydrogen gas combine with 1 mole of oxygen to produce 2 moles of water. So it's studying that. That's what it is.
Well, look at you.
Yeah. Look at me. I kind of feel bad now.
Nah,
I made these too hard, didn't I?
On to the equation.
Okay. Yeah. Here we go.
Okay. Good God. All right. We left off at alpha. Now we need to define H. So it's H sub alpha, which is very important. So that specific H can stand for height, or it can stand for the Planck constant. And I think that's going to be it. Okay. Because it is the quantum of electromagnetic action. We said that alpha stood the no, what did we say alpha stood for? Or Sommerfield's constant, which is also constant, dealing with electromagnetic.
Yeah, I think it was the constant.
So H is the Planck constant.
Nice job. Planck's constant. And we've got more chat. We've got some... See, Missing Music knew what stoichiometry is.
Oh, well, just aces. Thank you, Miss. You want to co-host a podcast? You probably do, but you can't. And it doesn't matter if I don't know what stoichiometry.
Wow, okay. Look. She didn't say it like that. She was just like, yeah, stoichiometry. And I was the one. So, take it out of me.
Yeah, stoichiometry. I'm going to build my Dyson sphere because I know what stoichiometry.
Okay, I'm going to... Moving right along.
Ladies and gentlemen, I'm full of NA.
I'm going to pick Biology 200.
Biology for 200. What a pretentious... I'm joking.
What? Okay.
What is the largest living animal?
The largest living animal has got to be the blue whale.
It is the blue whale.
Yay. Okay. I feel so bad now. I'm like, I made these impossible.
No, I'm joking. I'm totally joking.
Okay. So, your turn.
I'm smiling. Did you up your score?
I did.
You did.
I did indeed.
All right. I am just 0 for 2 in chemistry. Currently in chemistry, in actual 103% of the entire course.
Wow.
Just throwing that out there.
Okay, well, if you got 103%...
And I've gotten both biology answers out, which I'm on record saying first.
You should have gotten the chlorine one right, I just gotta say. It's a halogen. I should have. It's the 7 valence electron octet rule. Yeah. Anyways, so...
All right, let's go over to physics.
Nice.
Because that's the one of the three not hit on.
Yeah. So...
Physics for 200, Max.
Yes, sir. Physics for 200. Okay. What is Newton's first law of motion?
Newton's first law of motion. An object in motion.
Yeah.
Unless acted upon by a greater force.
Nice job. You got that one. So let's see.
Oh, yeah, I got that one. I got that.
Yeah. So, let's see. Okay.
All right.
1,200. See, you're not that far behind, so you're doing pretty good, you know?
What'd you say?
You're not that far behind, you know?
I'm not?
Yeah, you're at 1,200, I'm at 1,600. I think you're doing pretty good.
Yeah. Okay.
All right. Let's go with lightsaber colors for 400.
Lightsaber colors for 400.
Yep. Okay.
How many lightsabers has Anakin Skywalker been shown using in the movies?
Okay, how many lightsabers has Anakin Skywalker?
How many lightsabers has he used?
Okay, just once even. Okay.
Just once even. How many has he used? And
well,
I don't know if I should give you a... It could be as close as 1. But I will get, because this is the category. I will give you the aid that you can be one off.
Okay, let's see. So here's my rationale, right?
Yes.
He has his own. Was it green? I think he had his own, like, in the movies, in the prequels at least. So he had his own once he became a Padawan. Then he probably picked up Obi-Wan's at some point. I'm guessing maybe in the third one during the Count Dooku battle where Obi-Wan is like under a pillar or something, and I bet Anakin just... Oh yeah, no, I know that now for a fact, because he beheaded Count Dooku with 2 lightsabers, and I think the other one was Obi-Wan's, so that's 2. And then he became a Sith So then that's the third one with his red lightsaber. Let's see. And I don't think he's used any others. Because once he was a Sith, he didn't pick up other people's lightsabers. He's just stuck with the red one. So, and then he died. So that's 3. Yeah, I'm going to go with 3.
It is actually 6.
What? Oh.
So the ones that you were talking about are yes, specifically are his most well known, but through the entire 6 movies, he built the lightsaber. He built his first lightsaber, which was then destroyed on Geonosis, which is, I'm pretty sure, where Count Dooku was fought. Okay. That's just the name of the planet. Hold on.
Oh, the first
Geonosis was the... Is that where Count Dooku is? I think it is.
Okay. In the second movie, right? Okay.
Yeah. So, Geonosis, his very first lightsaber, his Padawan one, actually got destroyed there. Mm-hmm. But then he was given a second one on Geonosis, and then he picked up Obi-Wan's one after he was injured. Okay. And then he built another lightsaber, which was then stolen by Obi-Wan, and then that lightsaber, because that was the lightsaber he used after he got
when they were fighting. Yeah. Okay.
And that one was picked up by Obi-Wan in that scene.
Yeah. On Mustafar, right? Yeah.
On Mustafar, yes. Yeah. Actually, I'm impressed that you know that.
Yeah. Lava planet.
And then
the floor is lava.
He ended up giving that lightsaber to some little known guy named Luke Skywalker. Then, of course, he had his red-bladed Sith saber, which he actually built. And then he had one that he stole after Revenge of the Sith. Because even though it is the same crystal from the one that one of his previous ones, he did put it in a different lightsaber. So that is a total of 6. Just real quick, his first lightsaber, green one he was given, Obi-Wan's blue one, a second one he built, which was then given to Luke, one that he stole after Revenge of the Sith, and his red saber.
Well, all right. I feel sad.
Yeah,
I gotta.
No, that's the category you know as.
Yeah.
For that question, you had a
Yeah.
So
at least I had
on to the equation. Your first time at the equation.
Yeah. Let's see. At the chopping block. Okay, so after
I'm gonna eat some Takis.
Gonna get some. Okay, so then we've got phi, right? You see that? Phi.
Is that the next one? It is so. Indeed.
I'm gonna look up phi as used in physics. Wait, do you have like the site that you're on or something with the?
Yeah, I can.
Here, wait. Yeah. Could you give me that site? Where are you gonna put it?
Yeah.
Oh, did you put it in the Discord?
I'll throw it. No, I won't put it in Discord.
Okay, because then we'll have to show your.
Yeah, I don't want to.
Yeah. Okay, Tim.
I don't want to expose myself.
Okay, Tim.
The link is the link is on the slide with the equation.
Oh, okay. I see. All right. Let's see if there's phi. Do they have phi? Crunch. Oh, then there's Greek.
I won't eat if the crunch is.
I guess if you want to mute, you can probably do that.
Yeah, no, I can wait. Sorry about that.
Okay, it's fine. Okay, phi. So there's 2 types of phi. The second type of phi is electrical potential or Higgs field work function. So I'm no particle physicist, but I'm going to go with Higgs field work function.
I would say that is a very guess.
Yeah. All right, then.
All right.
So, it is now your turn.
It is my turn to receive.
Yeah.
I'm going to go biology for 600.
Nice.
The first venture into
the 600 territory. Yeah. All right. Let's see. I've got my document. Biology for 600. Okay, so what is the Krebs cycle?
Oh my God. Oh my God, I know this one. Oh, the Krebs cycle. No, no. No. No, 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 no. No, I've heard it. ATP? Something with ATP.
Yeah,
right?
something with ATP,
Something
yeah.
It's the cycle of ATP going through the body, getting received, and then the cycle of it going like back up and then getting dispersed and then coming back together. Here, I can be more specific.
Yeah. So where does it take place?
So,
where does it take place, this reaction?
In the DNA. No, not in the DNA. Not in the DNA. In the cells.
What part? Which organelle?
No?
Oh, sorry, you cut out. What?
The ER, the reticulum?
Nope.
Not the reticulum.
No. So this cycle is often simplified. It's often greatly simplified and referred to by another name in simple biology classes, but in AP Bio, this is like delved deeply into.
Isn't it? Okay, but hold on. Let me explain the cycle depth.
Mm-hmm.
Let me do that. It's a process of ATP being used and then reclaimed. Am I right on that?
I wouldn't No, I would say it's
the
production.
Okay.
The production of ATP.
The production of
ATP,
energy going out. So organelles by the ribosomes make proteins, so it's not them.
Mm-hmm.
The cytoplasm is just like fluid.
Yeah.
Well, it's plasma, but it's not the ER. It's not the that reticulum.
There's one organelle that you're forgetting about.
There's the Golgi apparatus?
No.
No, of course it's not.
It's the one everyone knows.
Oh, the nucleus? The nucleus.
No.
The nucleus.
No.
The one that everyone knows? The cell member?
Nope.
I'm going through all of them. Oh my God.
It is often referred to as the powerhouse of the cell.
It's the mitochondria.
Yep, it's in the mitochondria. So it's the production of ATP.
You can't give that one to me.
Yeah, I know.
That one was like terrible.
I was trying. So it's pretty much cellular respiration, aerobic cellular respiration. So it's the process by which our bodies turn oxygen and sugars into ATP to use for energy. And it's just simply called cellular respiration, but it's like a 32-step process. And that's the Krebs cycle, the 32 steps. So, yeah. Take your pick. What are you going to define?
I want to cry. Well, what's the next thing?
We've got some more. Missing Music says, Accelerated must be a good class, because I know this too.
Oh, you know damn well Accelerated is a terrible class.
Wow, we've got some drama.
Yeah.
Some drama.
I is our next variable.
I. What is I?
Is it? I'm guessing it's not the square root of negative.
I don't know. I feel like it might be.
Could it be?
Yeah.
It could also be intensity or radiance.
I don't think so.
No, it's not that. Okay, so yeah, it is.
Yeah, which is just goes to show how messed up this equation is. The square root of -1 is supposed to be an imaginary number, and then you get into complex numbers in algebra 2. they talk about how you won't use this in real life. This is just purely like mathematical abstractness. But then nope, standard model's like, let me snatch that up for you. And then it yeah. So anyways.
All right.
Next one. I'm going to pick particles for 400.
Particles for 400. That's a good choice.
Yep.
Particles for 400. Who performed the gold foil experiment and what were the findings?
Okay, so that is Ernest Rutherford.
Correct.
And the findings were that although he expected the alpha particles to go through the gold foil without being deflected, he found that 1 in 8,000 were deflected in random directions. And he concluded that that means that atoms must have a hard, dense nucleus for the alpha particles to deflect off of.
That is correct.
Yay.
$400.
Nice. $400.
Which puts you at 2,000.
Yeah, $2,000.
Okay. I'm slacking.
Slacking.
I'm not gonna lie. I'm kind of slacking.
Yeah.
All right.
So what do you pick?
Particles to hundo.
Particles to hundo. Nice. Okay. Let me pull up the particles for 200. Okay. So, which particles on the Standard Model have a negative 1/3 charge?
I'm thinking of the Mike Wazowski.
Oh yeah. That facial expression.
Okay, negative.
Missing music
Are you
objects.
asking for the,
She
are you
says,
asking
"Hey,
for the
it is a
group or
great."
the list?
It can be either. She says, "Hey, it is a great
Either.
class." Try and get the list, and
well,
if you can't, then just say the group. If you just get one in the group, just say the blank group. Let's just see what you know.
Okay. Well, it's got to be the boson group. No.
Are you serious right now? Are you serious right now?
It's not.
Negative 1/3 charge. Oh my god. It is the down quark, the strange quark, and the bottom quark.
Oh. Wow.
Yeah.
Awesome.
Yeah. So, yeah.
Yeah.
Yeah. Come on. I thought there was an
I don't
easy
have
one.
the charges memorized.
Okay. Well, some of us have the charges.
Yeah, okay. Did you know that one? Missing music? Did they tell you that in Accelerate? No, they didn't.
Let's see if she responds.
Because it's a
in
terrible
30
class.
seconds.
Okay, here we go.
Oh
Next
my gosh.
variable.
Yeah, next variable. I await Missing Music's response when she realizes in 30 seconds that she was just called out.
Yeah.
Okay, so which variable?
I'm having fun. It sounds like I'm getting angry, but I'm having fun.
Yeah.
Don't worry.
It's like when dogs are fighting each other and you're like, oh no, they're fighting, but they're really like play fighting. Even though they're growling and it's all
I'm just a
scary.
big puppy dog.
Yeah. Let's see what she
What
says.
is this? A crossover? Anyway.
What is this? A crossover episode? Sebastian and Max. Do they know things? What do they know? Let's find out.
Is M new? No, we did M, right?
I think we did M, yeah.
We had to.
Well,
lowercase
or uppercase M?
Yeah.
Which one?
Uppercase M.
Yeah, I think we did that. Was it mass, whatever, like something with Lagrangian stuff? Yeah.
Yeah. Okay. Have we done
Missing
S?
Music says some of us.
We've done S. S is strange.
Missing Music says, okay. The quote, some of us have the charges memorized. Oh my god, ahaha. That was so passive aggressive.
And then she's gonna realize that after the next in the next 5
seconds. You have all of 5 seconds to make your amends with the universe. You are about to be smitten.
Well, I'm sorry. But But that class is hot. Anyways, we're gonna
Wait,
keep
I
going
just
with
noticed
this.
something. Look at the bottom of the equation. Do you not see a punctuation mark? Just a period.
Okay, and her response is
Her response is
that, but now I do.
also
because
no. I did
watching the
not know
Gravity
that.
Max live
I do
stream
because-
is a great learning. Oh, now I feel bad.
Yeah. Now,
Okay,
now
I'm
she's
sorry.
Smiling emoji.
Accelerated is not a bad class.
It's a different path.
I am a fool. I am.
They
I am
played me like a damn
I'm
fiddle.
just not intelligent. That's what it boils down to. I can tell you all about quantum mechanics, but I can't tell you about the spin of the strange quark.
Accelerated science.
This is my formal apology. I'm sorry.
Yeah, you better make a good apology.
The Gravity Max live stream.
If you don't apologize well enough, we're gonna have to Twitter cancel you.
Yeah.
Okay.
So have you gotten to the next?
What?
Going through this.
What?
Like, have you found the next variable that's necessary for me to do? We've done A.
Oh yeah, we still have to do a variable. I forgot. Okay, so after 5,
IGS.
then there's capital H.
We've done that.
We did lowercase h, but what about capital H?
Oh, yeah. I guess we haven't.
Yeah, I know what it is.
Okay.
I think I know what it's got to be.
Okay.
It's got to be that one
capital
guy.
H
That
can
man.
be magnetic field strength, and I think that's what it is.
What? I think it's Higgs boson. It's got.
Oh, is it? Yeah. Oh, yeah. You're right. You're right.
Higgs
Sorry,
boson.
I'm looking at the physics notation stuff.
Yeah, I get it.
It's just we were just talking about magnetism, so.
Oh, that's true.
I was thinking about that.
Yeah.
But yeah. No.
It's just got to be Higgs. Yeah. Okay.
Yeah.
So now it's my turn. Let's see.
Oh boy.
Okay. I will pick Astronomy 400.
I'm sure you will. Okay, astronomy. Who is the first man to extensively detail Jupiter?
That would be Galileo Galilei. Also, Missing Music says, thanks, I accept your apology, my dude. So, it's all good.
Good.
Balance has been restored. Oh, so I get 400. Nice.
Yep.
Double Dutch.
Oh, okay. All right. I'm getting kind of shamed, but it's fine because it's a learning experience either way. Whether I get it right or wrong, you guys get to learn, and I'm willing to make that sacrifice.
Yeah, whoever wins,
because I'm a good guy. I'm also really tall. If you didn't know.
Yeah, there are no winners or losers here, because we all win so then I guess there would be winners. There are no losers here. There are only winners because we all learn. I messed it up. I messed up the inspirational quote. It's all chopped to pieces. Oh. So which do you pick?
Well, I'm ready. I'm ready to get hurt, Max.
Okay.
Give me astrology for 400.
All right, astrology.
I'm ready. I'm ready to get whipped.
Astrology.
I'm ready to.
I'm excited for you to see astrology for 1,000. It's gonna be
It's gonna be like what astrological sign was Joseph Stalin?
No. Astrology 1,000 gets personal to you.
Oh yeah. No. I'm so afraid.
Okay, so
let's do it. Let's
do
it.
So how is a zodiac sign determined? So it's the position of a celestial body. So which celestial body?
It's either the gun. Okay, wait. Hey. Let's slow down, Pally. When you say zodiac sign, is that Aquarius, Virgo, Cancer, and all that?
Yeah,
that's the month. That's just the month you were born in.
So what celestial body would it be if it's based on a year length cycle?
Then it would be the sun.
Yep.
Like the Earth's position.
Yeah, it's the sun.
Yeah.
Yeah. So basically, right, what happens is
I'll take that 400. Yeah.
Yeah.
I'll take it.
When you're born, right? Whatever constellation the sun is physically on top of in the sky.
Oh,
That is the one that
okay.
is yours.
Oh, I didn't know that.
That's how they do it. So, also, let's see, missing music. Also, if no one got things wrong, the equation wouldn't be explained, so it's a good thing.
It is a good thing. She understands me.
Exactly. So, let's see, what should I go for? I am going to venture into the 600. I'm going to say physics for 600.
Physics for 600?
Yeah.
All right. How many times heavier when it's in water? When it's completely submerged, what is the factor that it...
Sorry, you're cutting out. What is it?
Okay, sorry, hold on. I'll move my mic closer.
Okay.
When something is in water,
how
many times heavier is it?
Just... What? When it's in water, it's heavier? Wait.
Yeah, how much more force is required? Because it's the same mass.
Okay. Wait,
but
what?
it's harder to move.
Oh, well, I mean, that's just about the friction, right?
Yes, which is why it's in the physics category.
Okay. Well, if you knew correctly, physicists always ignore friction. Not really.
Okay.
No, but so there's a factor that water is more frictiony than air. Okay, I'm just gonna guess here, right? Water has a density of 1 kilogram per liter, and air has a density of 1.25 grams per liter. So I'm gonna go with 1,000 grams divided by 1.25 grams, which is 800 grams. So I'm gonna say a factor of 800.
That ain't it.
No. Okay. What is it?
It feels like something is 1.6 heavier than it actually.
What? Okay.
So, for example, if you threw so it's like WW, like weight in water equals like 1.6 times, or 2/3 the weight in air. So if weight in air is so it's basically that scalar thing. I think.
I have no idea. Wait, are you saying buoyancy?
No, I'm not talking.
Okay, whatever. I'm just gonna do an equation thing.
Yeah, hold on.
I just have no idea.
Hold on, no, this is the thing I was checking earlier.
Oh, okay.
How...
Missing Music says, Max, I'm just gonna guess here. Also, Max does a bunch of math to figure it out. Yep.
Yeah, so the 1.6 thing was actually the buoyancy force. But it is, what I'm talking about is kind of like going against that buoyancy force because of something like isn't buoyant at all.
What?
Well, I guess that was a handy dandy way to learn buoyancy force. Go to the equation, Max.
Okay.
Wham!
All right, I'm just whatever. I'm not even gonna contest it at this point.
Yeah, that was a rigged question. I'm not even gonna pretend, but
I am just. I still barely understand what exactly you were asking. Okay.
Me too.
Let's just say.
But that is exactly questions sound like to me.
Okay. I think I've been humbled here. All right, so let's see, next variable.
That's the feeling of not having to do an equation. I'm sorry. Missing Music. I feel like I'm teasing too much. I'm literally standing up, like roasting the hell out of your like class schedule. You do not have to hold back.
All right.
Anyways, on to the equation, letter boy.
Yeah. Okay. And that's a reference to our TV show because I always fix the screenplay format. Okay. Let's see. So I'm going to define gamma. Have we defined gamma?
I do not believe so.
Great, because gamma is a photon. Dab on them haters.
So I think you skipped one, actually.
I know, but it just said, you just said define a variable. We've just been going in order. Just
I was going in order. Okay, yeah, if we don't have to, then yeah, sure.
Yeah.
Okay, sorry. I thought we were going in order.
Yeah, I know. What was the one? What's the next one, though? In order, what was it?
The next one was beta, but I can take that one. I can take that one if you're going to define gamma.
If I get that wrong again, if I get something wrong again, then I'll take beta. Yeah. So, okay.
Okay.
All right. So, what do you pick?
I pick full send.
Full send?
Full send. No, not full send. Chemistry for 600.
Chemistry for 600. Oh, were you going to full send biology?
I was going to full send biology, but we're not doing it. Not today. Well, yes, today, but not now.
Yeah. Chemistry 600. What is the typical oxidation number of silver?
One.
Yes.
Oh, let's go! Oh!
Nice job.
1, ladies and gentlemen.
Yeah. +1. Nice job.
+1.
Oh my gosh. It always likes to lose 1 electron, which is why it's the best conductor, because it likes to lose 1 electron and just send it on its way. So, nice job.
Thank you.
Let me add a nice 600 to the score. That is 2,200. Oh, you're catching up.
That was no Google. That would have been way too quick to Google.
Yeah.
That was from my mind. Okay. That's big brain.
So now I have to pick one. I'll go with particles for 600.
Particles for 600.
Yeah.
Maximus Theobald Rudin.
Yes.
What is the definition of a lepton?
Okay, so a lepton is a particle that has a lepton number of 1, and that is a matter particle, such as an electron.
There's one big thing that you're missing. And I'm saying give me the dictionary definition of a lepton.
It has a -1 or 0 charge.
That's not it.
No, it's on the standard model. I don't know. It's an elementary particle, class of elementary particles.
The dictionary definition is a subatomic particle that does not take place in the strong interaction.
Oh, sadness.
So, unfortunately, you are going over to the equation.
All right. So,
that's right, missing music. Seb is making a comeback. Seb is happy, and Seb is talking in the person.
Okay, beta. I'm going to look up beta.
What did you call me?
Beta, the next variable.
I know. Oh, okay. It was a joke.
Oh, okay. Yeah, I know.
I'm not a beta.
I know that joke. Okay, so velocity in terms of the speed of light, or a beta particle. Now, a beta particle is an electron or a positron, but they already use E for electrons. So I'm going to say it's velocity in terms of the speed of light.
Yes. Yeah. I would concur.
You
Max.
Would concur? Nice. Okay. So what do you pick now?
Physics 400.
Physics 400. All right. Let's get a nice physics question. Okay. So the physics 400 says, okay, what is mass times velocity? What unit is it? So like what type of, you know what I mean, right?
Acceleration?
No, mass times.
Oh, mass times.
Yeah. Mass times velocity. So kilograms times meters per second.
All right, mass times velocity.
Mm-hmm.
M over V. Or no, MV.
Yeah.
MV.
Yeah.
MV.
What is MV?
MV. Hmm. All right, let's think about it this way.
Mm-hmm.
Mass,
Yes.
velocity,
Yep.
mass times velocity.
Uh-huh.
The mass of something
Mm-hmm.
times velocity of that.
Yeah, the same thing. So
It is m in parentheses v in parentheses.
uh-huh.
M asterisk v.
Yes.
Okay. I already know that force equals mass.
Uh-huh.
So it cannot be force and it cannot be acceleration.
Yeah.
I've ruled out two variables.
Nice job.
Oh yeah. All right, let's think about it actually. If I had a ball
Mm-hmm.
and I threw it,
Mm-hmm.
and that ball weighs 225, and the velocity of it was like that times a lot.
Mm-hmm.
What would we get from that? We would get trajectory.
What?
Trajectory.
No.
No.
First of all, trajectory is like the course that something takes.
Smart guy would.
Okay. The answer is momentum.
Oh, yeah, I knew that.
You did. Okay.
I did.
Well, you didn't say it, so off to the equation with you. Okay.
Back to the factory.
Back to the factory.
What else have we not defined? There's like X and Y down there.
Oh yeah.
Let me go over to D.
Yeah.
Because that D is that different than the ones up top, or is that the same? Because now it's big D down here. Actually, wait, no, I see lambda. I'm going
Okay.
for lambda. I'm choosing the easy way out.
Go for lambda.
So lambda, as we all know, can be length, can be a linear charge density, or it can be the eigenvalue.
Eigenvalue.
So
that's
the eigenvalue is the characteristic vector of linear transformation.
Mm-hmm.
So I think for the linear charge density, it deals with electromagnetism.
Mm-hmm.
And I'm not sure how wavelength would function unless it's talking about concurrency relating to spin.
Mm-hmm.
But I think it's going to be linear charge density just because of all the electromagnetism.
I feel like it's got to be wavelength.
How so?
This is our homeboy. This is lambda. Everyone knows lambda.
This is lambda, but you know what's not our homeboy?
That is true.
This equation has misused variables. Like C is not being used as the speed of light.
I know, but it's lambda. It's classic lambda.
But C is always the speed of light, and in this, not.
This would be like lambda being accused of like murder, and everyone's like, "What? Lambda would never do that. That's so out of character for lambda."
Okay, well, let's look at it. It's E. So it's E to the power of lambda.
Uh-huh.
So E is already electron.
Yeah,
it's gotta be.
I guess it's gotta be the wavelength of an electron's wave function. Yeah.
All right, I'll go with you on this one.
Okay, I'm just saying. I'm a character witness here.
Okay.
Everyone knows lambda. Everyone. It's like the jocks, the nerds, everyone likes lambda. You know, he comes in, he always breaks up the fights, but they get it. They're like, it's like cool, classic lambda. You know, he's just here to have a good time and be wavelength. There's no need to question him. No dark secrets lying under lambda's suave exterior. Everyone knows lambda. Anyways, so now I get to pick one.
Yeah, go ahead.
I'll pick astronomy for 600.
Astronomy for 600.
Yep.
What is the maximum amount of times that you can possibly see Halley's Comet in your lifetime?
I would say 1. Or wait, maybe it's 2. It's 2 probably. I'm going to say 2.
You're going to say 1 or are you going to say 2?
I'm going to say 2.
You don't sound sure. Are you going to say 1 or are you going to say 2? Give me a final...
I've said it, 2. I'm gonna
2
say
final answer? Well,
yes.
sir, unfortunately, it is 2.
It is 2? Nice. Okay.
It is 2.
Thank
it
you.
Comes once every 75 years. So if you live longer...
Gosh,
than that,
I said 2.
See it.
$3,000. I'm safe now. Okay.
For now.
I'm safe for now, yeah. So, what do you...
I think I want to even the playing field. Let's go biology for 800. Let me catch right up to you.
Ooh.
Let me breathe down your neck.
Oh, no. Like the robot one. Robot one. Okay. That's a reference. You'll get it later. Anyways,
yeah.
So... biology. What is an ectoderm?
Oh, piss off. If I know this. Ecto. Like ectoplasm. Ghosts. That's not it. Ecto. It means like translucency? No. Transparency.
I'm gonna give you something.
No.
So
okay.
There's ectoderms, mesoderms,
and then there's
endoderms. And endoderms. So
yes.
They're all in this subset of thing. So what's the ectoderm?
Okay.
Out of those 3.
The ectoderm. Okay, you see, ecto. So what were the other types of derm?
There's ectoderm, mesoderm, and endoderm.
Endo.
Mm-hmm.
Something has an endoskeleton.
Mm.
It's inside.
Yes.
Something has an exoskeleton. It's on the outside.
Mm-hmm.
Like an ant.
Yeah.
So, based on, I don't know what, but I would say it's relating to the space of where.
Mm-hmm.
So I would say that if endo was inside, then ecto would have to be being used as outside.
Mm.
Follow my logic.
Mm-hmm.
And it's the outside of the derm. Oh wait, derm. Like the dermis. So I know the outermost layer of skin is called the epidermis, and it's made of epithelial cell. I don't know, it can't be the outermost layer.
Sorry, you're cutting out a little bit.
So it can't be the outermost layer of skin because that's something else. That's the epidermis, which is made of epithelial.
Mm-hmm.
So the outermost layer of something.
Yes.
But it says derm. Derm meaning like skin.
But remember mesoderm and endoderm. So
yeah,
it's not necessarily skin.
Okay, yeah, not necessarily the skin. Okay. I'm gonna say the outermost layer. It can't be of an organism. Maybe like the outermost layer of like an organelle or a cell?
No.
What is it?
It is in cell differentiation in a fetus, it is the outermost layer. So this is when an organism is comprised of maybe 100 cells. There's the endoderm, which these cells, the endoderm cells become, I think it's bone, like internal organs and stuff like that. Then there's the mesoderm, which becomes parts. Like, so it's central and then middle and then outside. So the ectoderm becomes
Yeah, so I got it was on the outside.
Yeah. It becomes skin. I guess blood vessels, maybe. Yeah. Definitely skin, though. So.
Okay.
Yeah.
All right, next one in the thing that we have was that L?
Yes.
I think that's L. I think we've done L yet. L could stand for like lepton, or L could be length.
Ooh, this will give you some solace. Missing Music said, I knew this, but I forget. This was on my final exam. I'm so frustrated.
Yeah, I'm sorry I get this. Alright, L. That is an L, right? Not
it's a squiggly L, right? It's a cursive L.
Is it?
Where? Which
L? I totally lost my.
If it's a cursive
God,
L,
looking at this thing
I don't think it's lepton, and here's why. Do you see U to the power of lep? It literally says LEP.
Yeah.
So LEP has got to be lepton.
Oh, then that entire. Okay. Yeah, I was only looking at LEP. Mm-hmm. Okay.
Oh,
yeah,
L lepton. Amongst LEP. That's what you were looking at?
Yeah, exactly.
Oh, okay.
Yeah, that's what I was looking.
Yeah, so LEP is lepton.
Okay.
Bam.
Lepton.
Drop the mic. Okay, so now it's my turn. I shall pick something. Let's see. I'm going to say chemistry for 400.
Chemistry for 400.
Yep.
What is the name of the gas that makes your voice low? Contrast to helium.
Okay, so did you say noble gas or just a gas?
No, what gas makes your voice lower?
Well, there are multiple.
If you inhale it.
Yeah, you can have carbon hexafluoride. Is that the one you're talking about? There's also
that is not the one I'm talking about.
Wait, no, it's sulfur hexafluoride, and then there's
that's it. Okay, he's got it.
Yeah, there's also xenon and krypton too.
I'm gonna do a big crunch.
A big crunch.
Get ready.
I can't believe you actually got Takis. That's so amazing. Should I tell them why that's so amazing?
It's the great Taki flavor.
Yeah, it's the great Taki flavor. Okay, so what do you pick? Which thing?
Oh, isn't? Oh wait, yeah, you just did it so quickly.
Shoot, I need to give myself points. So, 3,400.
Okay, astronomy 600.
Okay, astronomy 600. Okay, so what is? Okay, so this one is what is Kepler's second law of planetary motion? But don't worry, I will describe it for you. Okay, so the second law of planetary motion is the one relating to. Okay, so Kepler's second law of planetary motion describes the speed that planets orbit on elliptical paths.
Okay.
So what is the rule that describes? So the rule is written like this. So it will take an equal amount of time for a planet to cross a certain amount of space as another area of space, as long as they have some factor that is equivalent. And you gotta, what is that factor?
As long as the gravitational pull on them is equivalent.
No. So it's the same planet in one orbit. So
same planet.
Yeah. So it's the same planet in one orbit. And so the distance it moves in one day when it's really far from the sun will be equivalent, not the distance, but some factor about this orbit will be the same no matter where in the orbit they are after one day. So
what is that factor that remains the same?
So how do you determine it? How do you determine if you have an equal time interval for a planet on an elliptical path at different points in the path? How do you determine that two distances along the orbit will take the same amount of time to cross? That's the question.
Well, wouldn't you just have to measure the distance to see if that is the case? Or am I going in the wrong?
You can determine the distance. So you
would determine the distance using like the arc length, right?
Kind of, but this is just more of Kepler's second law, and I'm trying to figure out how to say this. So, okay, so after 1 day of motion, you measure the distance that the planet has moved, okay? And say this planet is at perihelion, right? So it's at its furthest point from the sun. And after 1 day, you say it's moved 1,000,000 kilometers. And then the next, like all the way in winter, the planet is at aphelion, so it is at the closest point to the sun. And after 1 day, you notice that it's moved 2,000,000 kilometers. And you're like, why is it different? It's just been 1 day, either way. But you notice that planets move faster when they're closer to the sun and slower when they're farther from the sun. So what geometrical measure can you use to figure this out?
Oh, you cut out a little bit. Can you say that last sentence?
Yeah, so what geometrical measure can you use to determine if two distances along a planet's orbit will take the same amount of time to travel?
It wouldn't be geometrical measure.
Yeah. Now think of your ellipse and think of your sun at one of the foci of the ellipse. And think.
Oh, you would use the I said like an arc.
It's similar to an arc.
It's similar to an arc. It's like wouldn't it just be like a segment of that ellipse?
Yeah, like the area of a segment. Yeah.
Yeah, so like the area of that arc.
Yep, that's it. Yeah, so it's the.
Oh, nice. Okay.
If you take the focus where the sun is, and you draw straight lines to the start of this segment of the orbit to the end, and then enclose it by the arc and take that area, as long as the area is equivalent, it'll take the same amount of time to travel. So.
Okay. All right, I got it. Thank you for helping me. That path.
Yeah, it was difficult. It's hard to.
I'm a terrible student.
It's hard to ask about Kepler's second law, I'm realizing, if you don't know what Kepler's second law is. But yeah. Okay, so now I choose one. Okay, I will choose. Lightsaber colors for 600.
Alright, lightsaber colors for 600.
Yes.
How many black lightsabers exist in the Star Wars universe?
What? Okay. First of all, I just
How many black lightsabers
I just gotta say, I object to the fact that that's a thing, because it's a lightsaber, and the color black is the absence of light.
Maybe it doesn't exist.
I just gotta say, it's not light, but whatever. It's the Star Wars universe.
Yeah, maybe it doesn't exist.
Okay. Oh wait, it doesn't exist?
I said maybe it doesn't.
Oh, so this is a trick question? I have no idea. It might be. Now. I'm gonna say how many exist. How many exist? I'm gonna go with 3.
What'd you say?
3.
3?
Yes.
No, your final answer.
Yes.
3 is your final answer.
Yes.
That is incorrect.
What? How many is it?
There is only 1.
Darn it. What? Who has it?
I actually can't tell you that because that may or may not relate to another question.
Oh. Now I want to know.
Off to the equation. Go to China.
Go to China. Hopefully they'll see that next week. So, go to China. Okay. What do you want me to define? Let's see. It's such a jank version of Monopoly. Instead of
Yeah.
avenues like streets, it's countries, and one of the countries is China, and so then you get a card that says "Go to China."
in all caps, just says
so
"Go
scary.
to China."
And I'm like, do I have to? So let's see. What should I define? I will define. You see that letter, the lowercase. Oh wait, no, uppercase U. Let's figure out
I see it.
uppercase U.
Uppercase U.
Okay, uppercase U. Is potential energy or internal energy? And
my guess.
energy of a system is the energy contained within the system. Let's see. I'd probably go with internal energy.
That's what I would say.
Yeah.
Because
so the energy intrinsic to an electron. Yeah, that makes sense because that's kind of like or a lepton. That's kind of like its mass in a way, because energy and mass are related. So yeah.
Yeah. Great. Because E equals mc squared.
Yes, it does.
Bow.
Indeed. So, what do you pick?
I would actually say that I would petition for a 3-minute break so I could run up and grab some munchies for myself, and also just so we can leave it here for a second.
Okie dokie. Let's do that.
Just a 3-minute break. We will reconvene at 8:43.
Nice. Okay.
Just a little recess.
Yeah, okay. I'm gonna mute the stream audio. Okay, we're back. But not entirely back. But we're back. Okay. Oh no. I see that the Discord was on screen for a while. Okay, so I guess we're just waiting on Sebastian, but he'll be back soon. So let's see. Any more comments for commentation? And I will answer them. So this is interesting. Our stream is on a 30-second time delay, just because any good live show has a bit of a time delay, and 30 seconds is the minimum that YouTube allows. So it's like we have a time lag with chat, which is funny. It takes 30 seconds for someone to type something in chat, and then 30 seconds for us... Actually, no, not 30 seconds for us to respond, but 30 seconds for them to realize we've responded. So that's like a full minute between comment and...
I'm back.
Oh, hello.
Hi, sorry I'm late.
It's cool. I was just kind of talking to myself and the audience. So...
Okay.
Yeah. I don't know. We might get a comment. I was just like, hey, anyone want to comment something? But no one did. But that's fine. Okay, so...
But nobody came.
Nobody came. So what do you choose? We still have 4 viewers,
you know
so
what?
That's good.
I've been humiliated.
Uh-huh.
I've been desecrated, my image destroyed.
Wow. I apologize.
Max?
Yes.
I want biology for $1,000.
Wow.
For $1,000.
The big spender. The big kahuna. The white whale.
Yeah. My
$1,000.
dick.
Yeah, let's see. Okay, well, I kind of feel mean now. Define extragenic suppression mutation. Okay, so extragenic suppression
No, I got
mutation.
it.
Yeah?
Extragenic.
Mm-hmm.
Extra. A word which extra is in, much like extrapolation, which is what we do right here.
Yeah.
So here we go. Extra. The definition of the extra. Extra.
Oh, missing.
So yeah, there's like extrapolation.
Okay.
And then there's what's another word with extra in it?
Here, wait, 1 second. So
Extraordinary.
Missing Music says, yeah, I noticed the delay earlier. And then she also says, hi, Seb, what did you get?
I got a veggie burger with sweet potato fries. Don't worry. I know everyone at home got... No, I am not a vegetarian. I've not lost my mind. It is veggie burgers merely taste good.
Cool. So,
Anyway,
extragenic.
Okay, extra. It means going outside of it.
Yeah. Yep.
Yeah.
So outside.
Extra. Genic. Genic has to be genes.
Mm-hmm.
Not the kinds you wear.
So
the kinds
outside
that
of
are
a
in
gene.
you. Right. So outside the genes. Okay. Extra. What was the second word? What was the second word?
Suppression.
Extra. Okay. Oh, hold on. Extragenic suppression. Outside of the genes being suppressed. Now, this is biology. So I have 2 leading. Present them to you.
All right.
Extragenic suppression, where the genes start suppressing factors that are like side of it. Like your genes suppress
Sorry,
or
you're
like
cutting out.
Yeah. All right. So your genes start suppressing like different aspects of your body.
Okay.
That's one leading hypothesis. Second hypothesis, it is an outside force that is suppressing your genes, which is in relation to evolution.
And then remember, though, it's an extragenic suppression mutation. So it's a mutation.
Oh, mutation. There was a third.
Yeah, there's a third word. So it's a mutation that's doing the extragenic suppression.
Extragenic.
Now, I would say extragenic and suppression are both adjectives relating to the word mutation.
Mutation, yes.
So it's a mutation that's extragenic and that suppresses something. So
wait, it can't be a mutation outside of...
Yeah,
right?
It's not the genes, it's just a gene.
Okay. Here's my definition.
Okay, what's your definition?
A mutation that occurs
Uh-huh.
which in turn causes a sort of domino effect where it ends up suppressing the effects of other genes. So it's a mutation in one gene that ends up suppressing others.
Yeah.
Yeah?
So here's exactly what it is. That's pretty close, though.
Okay.
I would give it to you.
Oh my god, let's go.
So
let's go.
So an extragenic suppression mutation is a mutation that suppresses another mutation in a different gene. So say you have this one gene that codes for a protein that, say it codes for the cones, the blue cones in your eyes, the blue light detecting protein, right? So your blue light detecting protein is all messed up because of this one mutation.
Yeah.
So then an extragenic suppression mutation comes in to save the day from a different gene and says, no, that is not a mutation anymore. I don't know how it does it. It just kind of like either it codes its own protein, like a spare copy, or it like fixes the protein, like it could be a second protein that fixes the messed up protein. But either way, it's outside of the gene in question, and it's a second mutation that fixes the first mutation, which is pretty fun, pretty lucky. So, yeah, 1,000 points.
And for the first time this game, I've pulled ahead of Max.
Wow. Well, let's just see. We'll see about that.
Yeah.
Let's go biology for 400, because I've been neglecting the biology.
Yeah, we've been doing the opposite. I've been neglecting things such as particles and my astrology column, whereas I have also destroyed my biology column.
Mm-hmm.
And okay, biology for 400, was it?
Yep.
Biology for 400. What part of the plant cell holds the chlorophyll?
Oh, the chloroplast.
That is correct.
Yay. Nice. So, 400. And we are neck and neck.
Mm-hmm.
Even split. Fractal Man versus the dimensional shifter.
The phaser.
The phaser. So, what will you pick?
I've been neglecting particles ever since that embarrassment. I think I gotta go particles for 400, Max.
Nice. I'm excited to get to particles for 1,000.
I'm gonna get spanked.
It's a fun one. It's a very interesting thing. Okay, so particles. Which particles have a plus 1/3 charge? Now just think about it. What?
Okay.
Think about
Last time it was the strange quark and the charm quark.
And last time it was minus 1/3. So what would be
that had minus 1/3? Yes. So I'm gonna say the.
And remember, I just gotta say, there are both particles and antiparticles.
Wait.
Both particles and antiparticles exist. So you gotta consider both.
The top and bottom quarks. That not it?
No.
No?
No.
Well, that was a college effort.
Okay, the bottom quark was one of the ones last time that had minus 1/3.
Wait, what?
Yeah, and we're looking at plus 1/3 now.
Yeah, wait. I said top and bottom. Last time it was the charm quark and the strange quark.
No. It was the down quark, the strange quark, and the bottom quark.
Oh. I thought you said strange and charm.
No.
Is that what this is? Is it strange and charm quark?
No.
No, okay. Well, Jesus.
Okay. It's okay. It's the anti-down quark, the anti-strange quark, and the anti-bottom quark. because those had minus 1/3 charge, so their antiparticles have plus 1/3 charge.
Well, don't I just have mud on my face?
Yeah. Go to China.
Yeah.
Let's see.
Okay.
What's the next variable?
I'm going to go... We have capital C. Have we tackled that before? You think capital C is the speed of light? If lowercase c is the thing in the series?
I don't think so. What does it say in the Wikipedia
Okay, in the
page?
common physics notations, capital C stands for... Oh, God. I don't... How do you even pronounce that?
Let me see.
Capacitance? Capacitance?
What?
I think that's it. Capacitance.
Capacitance, heat capacity, and constant of integration. Oh, I love constant of integration.
You think that's what it is?
Not really, but I love it.
Okay.
It's your plus C when you're integrating something. So.
Okay.
So it's capacitance in the unit of farads. What is a farad?
Farquad.
It is a 1 farad modern supercapacitor.
I think it is that, though, because that responds to an electric charge, whereas the other thing is just heat or thermal capacity.
Yeah.
And it's relating to... What did we say lowercase u was?
It was... Well, wait. Lowercase u. We did uppercase u. We didn't do lowercase.
Oh, we haven't done that yet. Okay, so I'm going to leave it there. I'm saying it's capacitance.
Capacitance.
How do you pronounce it?
No, I don't know. Just, even if that's the way to pronounce it, I don't like it.
All right, goodbye, missing music. Missing music is now missing.
Missing music. Wow. I guess it's her bedtime. Too late in the night.
It's too late.
The night is still young. It is only 9 o'clock. Last time we stayed up until 7 a.m. So
yeah. So
I am.
Yeah.
We're only through like half of these questions, maybe 2/3. Okay, we'll get these done probably by like 10. Anyways, So let's see. Now I get to pick something. I'm gonna say particles for 800.
Which one for 800? I didn't hear you.
Particles.
Particles for 800.
Yes.
Which one of these is more mass?
Okay.
A W boson or a Z boson?
Ooh. W boson or a Z boson? Z boson?
And there's a secondary part to this question.
What's the second part?
By how much is it more massive?
Oh. I'm going to say Z boson is more massive by 10 mega electron volts.
Are you kidding me?
What?
That's exactly correct. It is a Z boson by 10 mega volts.
Wait, really? What are the values?
It is W boson is hanging around like 80, and a Z is 90.
Wow.
You got it exactly.
Huh. Well.
Oh my god.
Luck be in the air tonight, right?
Oh, not for me. I must be breathing some other different kind of air, some different brand of air.
Maybe it's air in China.
Okay. Go to China.
Go to China. Okay. So, also, Missing Music says, it is 9. That is not my bedtime. Lamau. Anyway, bye.
Yes, her bedtime is 9:15.
And why are you leaving? That is the real question. If one is not leaving for bedtime, then what are they leaving for?
Then why? She's going to China.
Go to China. She took the command too literally. Anyways, so what do you pick? No more biology for you.
I understand now. I never understood before the phrase "pick your poison." Mm-hmm. Now I understand. Every option in front of terrible. So let's go for the worst one. Astrology 600. Lay it on me.
Astrology. Astrology for 600. Here we go. So, the 12 astrology signs are divided into 4 groups of 3 signs each. And it's according to what common aphorism? So the most common group of 4. You always think of 4. It is not by season. It is not by season. I'll give you one more guess.
Okay. Sorry, I thought you meant it like that.
It's a very metaphorical thing that you see coming up a lot. And it's a group of 4.
I see coming up a lot. A group of 4.
Yeah, and you got 2 pairs of opposites in this group of 4. So you've got blank and blank are opposites, and then you've got blank and blank are opposites.
Well, I'm gonna level with you, Max. I down and watch Avatar: The Last.
Yes.
The Elements. Yes. Okay, let's go.
Yes, it is.
Yes.
Water, earth, fire, and air.
Fire and air.
And
Beautiful.
So astrology signs are also divided into those subsets. So there are 3 air ones, 3 water ones. So yeah. Okay, so that is 600 points, which is 4,400. Nice. Okay, so now I get to pick one. Let's see.
Go.
Yep, I get to pick one.
Yeah.
Let's go with lightsaber colors for 800.
Lightsaber colors for 800.
Lightsaber colors for 800.
Which lightsaber color?
Mm-hmm.
So, out of the lightsaber colors that there are, which lightsaber color denotes that a synthetic crystal is being used in the lightsaber? There is one color that tells you that a synthetic crystal is being used in that lightsaber. What color is that?
Okay. Is it yellow?
Is that your final answer?
Yes.
That is incorrect. It is red.
Oh, that is a good metaphor or whatever. Nice job, George Lucas. Because they're the Sith and they're evil. So, of course, they would pick. And, if there's one thing that boomers such as Lucas like to say, it is technology bad. So, of course, the synthetic color would match the evil, the bad guys, the Sith. Makes so much sense now. Okay, let's find a thing. U. The lowercase u is the up quark. Bam, I'm done.
I literally hate you.
Your turn. Your turn to pick one.
Let's keep this train going.
Mm-hmm.
Astrology 800.
Astrology.
Give it to me.
800. Okay.
Ow.
All right. Astrology 800. Okay. So there are 3 countries that first used astrology. If you just say one, then I'll give you the point.
China.
Yes. That is correct. Go to China. Okay. So
go to China.
So you get 800 points. And that puts you up at 52. And I'm slacking now. So let's see.
You're slacking, Max.
Slacker, Max McFly. You're a slacker. Okay. Let's pick astronomy 800.
Astronomy for 800.
Yep.
What was the name of the first dog in space?
Ooh. It is Laika.
That is correct.
Love
and who
Laika.
shot her into space?
The Soviets, of course.
And how you got it right, but how quickly did she die? common
Oh, I
knowledge.
think it was like a few hours, right?
Yes, that's correct. The Soviets actually tried to cover it up and said that she died like a week in, like peacefully in space, but that's not the case. Yeah. She died of overheating in the first couple of hours of takeoff.
Yeah. Did you know that Laika was just a stray dog from the streets of Moscow?
Yeah, she was.
And in my book, they have the space station that's between the Earth and the Sun at the first Lagrange point is called Laika 1. Because of Laika, and also because Lagrange points are referred to as L1, L2, L3, L4, and L5, and this is L1. So Laika 1 can also be abbreviated to L1. So it's like, bam, double meaning. Yeah.
Bulgaria.
Oh, you'll get that when we play the game too, with all the countries. It is a fun game. Rento.
It's so good. I'm so glad you found it.
I know. Okay, I just looked up Monopoly online and I found Rento, and I'm like, let's see what this is. And Rento, it's Monopoly, but they didn't get the rights to Monopoly. That's how I would describe it. Yeah.
Give me chemistry for $800.
Okay. Chemistry for $800. So what does the symbol delta mean above an arrow in a chemical reaction?
What does the symbol delta mean?
Mm-hmm.
Delta often means a change.
Mm-hmm.
So a change over like a chemical. So like it's over a chemical, right?
No, it's in a chemical reaction. You know the arrow in the chemical reaction? It's above the arrow. So it's a delta sign above the arrow.
You mean it's the catalyst?
Yeah, that's where the catalyst goes, but it isn't. In a way, it is a catalyst, but it isn't a chemical. So it is what causes the chemical reaction, but it is not a catalyst. In a way that, a catalyst, say if it was manganese dioxide, right? Is that a catalyst? That goes above the arrow. So too does this go above the arrow, although it's not technically a catalyst, it does cause the reaction. If the reaction has this there.
The reaction. So would it be an outside force? It would be an outside force, right? Yeah.
So it's an outside application of something.
Outside application of energy?
Yes. What form of energy?
Heat energy?
Yep. Yes. Correct.
Yes!
Yes.
Oh my god! The jukes! The guess!
Yep. So it's
Maximus said yes!
It's basically when you have a reaction that is caused by heating something. So if you think of...
Let's go.
You stick some week-old pizza in the oven, that is now heating up and burning, and that is the reaction. Those reactions that is occurring inside of the pizza would have the delta symbol next to them. And also, I rescind saying week-old. I would say day or two old, because a week-old would be just gross. So,
I have eaten week-old pizza.
Oh, how dare you?
I was hungry.
You were hungry.
Okay.
So I get to pick something now. I will pick physics for 800.
Physics for 800 graviton bucks.
Graviton bucks, yes.
In the field of quantum mechanics, how is time viewed? Now, to put this into perspective, in the field of general relativity, time is viewed as relative. Now, in quantum mechanics, how is time viewed?
Well, I guess it would be viewed as absolute, because quantum mechanics does not go well with relativity. So I guess quantum mechanics just sees it as an axis, just a dimension of change you know.
That is correct.
Yay.
Quantum mechanics sees time as a constant.
Nice.
No matter at what size, scale, or dimension, time is a constant.
Quantum mechanics or the quantum mechanic specifically? The man, the myth, the legend.
Oh, the man, the myth, the legend.
Does he see time as a constant?
You know, I think he does. Let me tell you why.
Mm-hmm.
The quantum mechanic is known to be able to fix anything.
Mm-hmm.
So the quantum mechanic, anytime that time gets a little out of whack, anytime
he fixes it,
someone and their grandson like teleports back to the future to like make out with his own mom or like whatever. Anytime someone does that, the quantum mechanic is there to fix that time, which explains the reason. And he is the sole man keeping time intact.
Okay.
Anytime you have a plot hole in a time travel movie, the quantum mechanic is there in the background fixing time.
So I have a question, a follow-up question, and it's a bit more pressing, a bit more urgent. How does Silas view time? Does he see it as constant or relative?
Silas is the exact antithesis to everything the quantum mechanics stands for. The quantum mechanics stands for order and laws, whereas Silas orbits around nothing but pure chaos. Silas sees time as relative, but beyond that, he sees time as relative to him.
That is scary.
It is scary.
We need to find
Don't shake
Silas.
his hand.
Do not shake his hand.
Do not shake his hand.
He will enter the chorus of people in the background. Oh. Like at the end of The Shining with Jack in the photo.
Exactly like the end of The Shining.
That's what'll happen. You'll find yourself in the stock photo. Ooh. Anyways, so with that foreboding and frightening image fresh in our minds, which topic do you pick?
I'm going to go with... Oh, that's mine. I am 0 for 2 on particles. Let's fix that.
Let's fix that. Let's
talk
talk
about
about
600.
Anyways, particles. Okay. So, what is the most massive particle in the Standard Model?
The top quark. No, the up quark. The up quark. The up quark.
No.
The up quark.
No.
No, the top quark.
No.
What?
It is the Higgs boson.
No!
Oh wait, shoot, no, you're right. It is the top.
Okay.
The Higgs boson is second. I apologize.
It's the top quark.
I must
retcon. The top quark.
Yeah, okay. Sorry. I had that wrong. I had suspicions. I was like, wait a minute. That doesn't... So yeah, you're right. Top quark.
Oh.
It is 173 giga-electron volts, and the Higgs is 124.
Ooh.
Okay.
I was scared.
I apologize to you and to the audience, for I have made a grievous error. Anyways,
a grievous... Oh, it's fun.
Should I pick lightsaber colors next? Just because I said that? I think I have to. I think I'm legally required because I invoked the name of General Grievous.
He is my favorite Star Wars character, actually.
I know. He's pretty fun. I like him.
Out of anyone, he is my favorite.
Okay, so 1,000.
General Kenobi. Hello there. All right. Lightsaber colors for 1,000. Mm-hmm. Are you ready? You realize that... Oh, wait, no, that isn't the first 1,000 question. I took that first 1,000 question.
It's my first 1,000 question.
Yeah. The man who crafted the only black saber in existence.
Oh.
What race was he?
Oh, like what species?
What species, what race, any of that. You know that this race exists. You absolutely know that this race exists. What race was he?
Let's see. So I legitimately have no idea.
Here's your hint.
Okay.
I 100% guarantee that you know that this race exists.
Oh. Do they look just like people? Is it just like from a specific planet, or are they like really?
I would say that they look very similar to people. Yes.
Okay.
Their popularity and not okay. So I would popularity have gone up quite a bit in recent years.
Oh.
Because of the material that Disney.
Okay.
Of this rate.
Thinking it's either Yoda species or Mandalorian. I'm gonna say Mandalorian because I actually know that name instead of Yoda species. So.
Is that your final?
Yes.
That is correct.
Nice.
There you go.
Yay. Mandalorian.
Well done.
Wow.
The man who crafted the only black saber in existence was the first Mandalorian Jedi.
Huh. The more you know. Mandalorian. The more you know. Well, that's great. Okay, so what
well
do
done.
You pick? Thank you, Mandalorian. Baby Yoda. So, which topic?
So you've been helping me a lot in this topic, so I do not want help in this next one. Give me astronomy for $800.
Okay, astronomy for $800. All right, I'm going to give it to you straight. Let's see. Okay. Astronomy. Okay. This is straightforward. At 80% of light speed, time dilation makes the passage of time move at what percent of standard?
At 80% of light speed.
Yeah, so at 80% of light speed, what is time dilation? Like what percentage?
80%.
No.
No. Okay. It was the only number I had. Only piece of debris I saw.
Mm-hmm. Yeah.
What is it?
The answer is 60%.
What was it?
60%.
60%. Okay.
Yeah.
That's all right.
I chose 80% because 80% and 60% are nice numbers. Also, at 60% of light speed, time moves at 80% of the normal pace. So they correlate. They go with each other.
Nice.
Yeah. So.
Okay. On to the equation.
Yeah.
All right. I see. What is that? Like K? Or is that some Greek number?
I see the K.
Is it K? Hold on.
Looks like a K.
So K can stand for the Boltzmann constant.
Ooh, I know Boltzmann.
Okay. Yeah, so, okay. For our audience, it is a physical constant that regulates the average relative kinetic energy of particles in a gas with the temperature of the gas. It can stand for wave number, so spatial frequency of a wave.
Okay.
Or stiffness, the extent to which an object resists deformation in response to an applied force. Just going to look and see if there's any Greek symbols.
It was an uppercase K, wasn't it? It's got to be kinetic energy.
No, I'm looking at. I am looking at the. If you look at one of the last things, it's like it has m to the power of k.
Oh, and it's a lowercase.
I can't tell if it's really small. I can't tell if uppercase or like
one of the last things in the equation.
Here I'll count it from the bottom. It appears. Okay, the eighth one from the bottom. You have u power of k negative m to the power of k sub u.
Wait, what?
8th from the bottom.
I do not see it.
Maybe go up one more.
Yeah. Oh, m sub u to the power of k.
Yep, there you go.
Okay. And then d.
And then lambda sub k, which makes me think that it is the frequency thing.
I think it's kinetic energy because it's a capital K.
You think?
Yeah. So it's like the energy.
It is capital K. But do you think it's kappa then?
Ooh, what's kappa? Let's see.
Kappa stands for no, torsion coefficient. Yeah, it's not.
Oh,
okay. Yeah. So yeah, it's kinetic energy. That's one mystery solved.
Nice. Okay.
Okay, Max.
I get to pick.
My serve.
Yeah. Let's see. Okay. I will pick biology for 600.
He's going to take biology for 600.
Yep.
What animal did Charles Darwin famously study for evolutions concerning the beak?
Ooh, okay. The finch.
That is
Galapagos.
Correct.
Yeah. The Darwin's finch at the Galapagos. That's fun. I read on the origin of species last year in bio.
As did I, actually.
I also read The Elegant Universe, which isn't very bio-y, but I don't know. The school's like, sure. It's funny what the 8 choose, but well, it was kind of a your choice thing. It was a book club, but you know. Anyways, so yeah, I've read The Origin of Species and The Elegant Universe. So yeah. So I guess it's your turn.
Okay.
So what do you pick?
I will take chemistry for $1,000.
Nice. Chemistry for $1,000. He's done it. The Mad Lad. Okay. Chemistry for $1,000 is... Okay. Define ligand. What is a ligand?
You got it. Okay.
It is the
ligand. Ligand. Ligand.
Ligand. If that helps.
Well, so liga could be in relation to a ligament, and a ligament is used to connect two bones to each other.
Mm-hmm.
Does it have anything to do with connecting?
It does.
It does. Okay. And then it's just D and D. So it has to do with connecting.
Mm-hmm.
You've asked me a lot of questions about cells.
Well, that was in the biology section.
That is correct. This is the chemistry section. Okay, chemistry section. A ligand. A ligand connection. A connection of a ligand. Ligand connects.
I will say it is probably organic chemistry, because organic chemistry has the more complex molecules in it, I'd say. And a ligand is a class of molecule or ion. It's a molecule or ion. And it connects to something so that it can be transported around the body easily, like so that biological systems can handle it more efficiently. So it connects to something.
Like oxygen?
To hold to it.
Connects to oxygen?
Not oxygen. No.
Not oxygen. Okay. All right. Give me one more chance. All right. With this. Okay. To be transported around the body, so it can handle it more easily. So oxygen is transported around the body, but we said that's not it.
Mm-hmm.
Carbon dioxide is also transported around the body.
Mm-hmm. It's not a specific thing. It's a class of things that it transports.
It's a class of things.
And they're elemental, so on the periodic table.
If you said it was organic, then it would be non-metals.
Well, no. I mean, the ligand itself is organic, but what it carries is not necessarily organic. Yeah.
Okay, here's my final guess.
Okay.
A ligand helps the body tolerate acids.
No.
No. I gave that a college effort. Can't be mad.
So the ligand, a ligand is a molecule that holds a metal, so an atom of a metal, just holds onto it for safekeeping. So think of hemoglobin. Hemoglobin without the iron, the part that holds the iron and surrounds it, that is the ligand. So that's what a ligand is. Because metals are very reactive in the body. So, like, think of rust and corrosion. You don't want that to happen in your body. So the ligands come in and keep the metals under control. They make them behave. Yeah.
All right. Off to the equation.
Off to China.
I see a J, and I'm pretty sure that stands for Joule. Let's go back, ladies.
Okay. Wait, where is that J?
J is near the middle.
It's a lowercase J. Joules are uppercase J's.
It's another imaginary unit.
What?
Yeah.
What?
Yeah, it's an electrical imaginary unit. Go to the
I see.
The link that I gave you.
Imaginary unit or unit imaginary number is a solution to the quadratic equation x squared plus 1 equals 0. Although there is no real number with this property, I can be used to extend the real numbers into blah 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 blah. What about J? Okay, let's just say it's Joule.
Bam.
No.
Okay. My serve.
Wow. Okay.
You want?
I'll take chemistry for 600. Trying to even think.
He's going to take chemistry for 600.
Yep.
What state of matter is glass in?
Glass is a solid.
That is not correct.
No. I know you think it's a liquid, but it's not a liquid. I watched.
If you can give me the specific name, because it is a type of solid, but it is not a solid. It's a type of solid, but it's not just a solid, I should say. Oh. If you can give me the specific name of the state of matter, I'll give this to you.
Well, no, aren't you? Is this the myth that
it is not a myth?
Glass runs, because glass does not run. It does not change shape.
It is not a myth.
It does not change shape over time, though.
And that's also not what I'm talking about.
Oh, okay. Because there was this video I saw on it where it was like old glass windows always had, like, they were always thicker on the bottom than on the top. So people were like, maybe glass is just a really viscous fluid. And then someone's like, no, they just built it by putting the part that was thicker on the bottom for structural integrity because it was imperfect glass. Okay, let's see. Let's say it is intransigent. That's what I'll say. It's an intransigent solid.
Well, that is a valiant guess. That is not correct.
What is it?
It is an amorphous solid.
Darn it. Amorphous. Okay. Well.
Did I cut out?
No, I heard you.
You got it?
Yep. Well, that's truly sad. Okay.
You hate to see it. Off to China.
Off to China. That is unfortunate.
You hate to see it.
Okie dokie. After J, we have... My eye is hurt. Okay. There's an X, right? We didn't do that yet. So
we have not.
Let's see what X means. X. Well, they don't have capital X, so position vector, displacement, a generic unknown. What if there's a Greek letter that looks like X? Well, nothing. I have no idea.
Well, you can't leave until you do have an idea.
Leave. Maybe I'll just pick a different...
Maybe you will.
A different one. Wait, are there any others here? We've done E, right?
Yep.
Have we done D?
Yep.
Have we done S?
Yep.
Have we
Wait.
though?
Yes, we said it stood for strange quark.
Dang it, because I was going to say that again. Oh, I see a capital R.
Where? What
So
line?
it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 from the bottom. And it is minus 1/4 of V with a, or probably nu sub lambda times M sub lambda K to the capital R.
I see it. Yeah, I see it.
So, what is capital R? It is electrical resistance, Ricci tensor, radiancy, or gas constant. What is the Ricci tensor? Okay, I don't think
it's something that represents the amount by which the volume of a narrow conical piece of a small geodesic ball incurved. I can't even read this. Incurved Riemannian manifold deviates from that of a standard ball in Euclidean space.
Ugh.
That's the worst sentence ever.
I'm glad we're playing Rento next week.
Yeah, I think for you, for like, if to help you out, I would say it's
Okay, electrical resistance, sure.
Because they could be using the convert or the inverse of electrical conductance.
Ah. Cool, okay.
All right.
So,
it is my swing.
Yes, it is. What do you pick?
I'm going to go.
What'll you have?
You know what? I'm going to save Astrology 1000 until the end. I'm going to save that.
Nice.
I'm going to take
with
physics for $600 Maximus.
Okay. Sebastian, your name does not get any longer, which is sad. Okay.
Yeah.
Okay, so describe the unit watt as a product or like quotient of kilograms, meters, and seconds.
Of a what?
The watt.
Of a what?
Watt.
Of a what?
Watt.
Of a what?
Yes.
Of a what?
Yes.
Of a what? All right, this joke is not. Okay.
So yeah, you get it.
Restate
right?
the question.
Okay. Well, so here, you know how
say the question again.
No, let's hear. You know how newtons
No,
are...
God damn it! Say the question.
Okay, it is describe the unit watt as a product or quotient of kilograms, meters, and seconds.
It is kilograms over meters times seconds.
Kilograms over meters times seconds squared. Is that your final answer?
That is my final answer.
Okay, the real answer is... The real answer is...
The non-stupid answer is...
Is kilograms times meters squared divided by seconds cubed.
Oh my god.
Because it's joules per second. That's what a watt is. And joules, which measures energy, is kilogram meters squared, seconds squared, as in mc squared, mass times speed squared, and then per second.
Right.
So
you're going to have to change that one to white?
I am going to have to change that one to white.
A sad day. Back to the sweatshop.
Oh, God. Wait, did I get the last one right? No, right? Yeah.
No, you did not.
Okay. Cool. Okay.
I see an uppercase G, but we've already done gluons, and gluons were lowercase g. All right, so uppercase
what's the
G.
uppercase G? Where is it as well?
1, 2, 3, 6, 7, 8 from the top. Same line that had the K. You have anti-GA, whatever the hell.
Wait, what?
1, 2, 3,
capital 4, 8 from the... 1,
yeah,
2,
8. It was the same line that had the K, capital K.
And the beta at the beginning?
It's 8 from the bottom.
Okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, there we go. There's a ton of them.
Sorry. Did I say from the top? I meant from
you
the
said
bottom,
from the top.
if I did.
It's okay.
Sorry.
It's cool.
Okay, so capital G can stand for electrical conductance or gravitational constant.
Ooh, I say gravitational
I think it's gravitational constant.
There we go. Because while the standard model does not work with relativistic gravity, it does work with gravity as a thing that exists. So, bam, gravitational constant. Okay. So, we're probably getting this so wrong.
Possibly.
I'm gonna say whatever percentage of these questions we got right is the percentage of that we got right. So that's gonna be my guess. So it is my turn. I will take
it is.
Biology for 800.
Wonderful choice.
Thank you.
We just got that imported.
From where?
China!
Oh no. Send it back.
I'm giving you the chance to be either 1% lower or 1% higher. What's the word for that again?
1% lower, 1% higher. I guess percent error, right? Or
well, I'm giving you wiggle room is what I'm giving you.
Okay.
So here you go. You get wiggle room of 1%. 1% higher or 1% lower.
Okay.
What percent of our DNA do we share with chimpanzees?
That is 98%.
You are incorrect. It is 96%.
Bruh moment.
Bruh moment when you were one off, because I would have taken 97.
Okay.
Bruh momento.
Back to the equation. So...
Okay, off to the equation. What you seeing?
There's nothing left except x, but I don't even have the slightest clue what that can mean.
Yeah, have we hit every variable?
I think so.
Okay, then here's the new punishment. You have to read a line
out loud. Oh, you just read a line?
Yeah, just read it. It's terrible to say. Go ahead.
Just the letters, or should we say the variables? Like, should we say...
You can say the variables.
So, like, partial derivative... Okay. So, the Lagrangian Standard Model is equal to negative 1/2 the partial derivative with respect to nu. What was nu? Nu was frequency. The frequency of gluon subscript... Wait, should I just say G subscript mu? G subscript
you can just say it. Okay. You don't need to say what it means. Okay. Just say it.
LSM equals negative 1/2. I don't know that. I don't know whether was that in Greek. This is...
Okay. It's...
What's that letter? Backwards 6, nu. G subscript mu.
It's... Wait.
Superscript
what the hell is that?
Partial derivative nu. G subscript mu superscript a.
It's the der. It's the der. It's the der.
Okay. Minus G subscript s times f to the power of ABC der mu G subscript nu superscript a G subscript mu superscript b G subscript nu superscript c minus 1/4 G subscript s squared f ABC f ADE G subscript mu to the power of b G subscript nu superscript c G subscript mu superscript d G subscript nu superscript e. Straight bars right here. Minus
honestly.
Der subscript nu times W plus subscript mu times dir subscript nu times W minus subscript mu minus, and that's my quota. Shift
there
is
you
over.
go. That was a scrapped Dr. Seuss poem, by the way.
Honestly, so it is your turn now. Which
all right, all I've got left is 801
yeah.
vowels. So
I've
been
left
shamed,
except Spider-Man.
embarrassed, humiliated, some would say,
in
this hullabaloo of questions. So
hey, don't bring up hullabaloo.
Let me get particles for 800 dollars.
Dollars. Okay, particles for 800. So what effect does replacing electrons with muons have on a hydrogen molecule?
It makes it a neutrino.
No.
No, it doesn't make it a neutrino. It makes it a cation.
Well, it doesn't make it anything. So you have, remember, muons are heavier versions of electrons. They're more massive.
Yes. Yeah.
And so muons are heavier. And if you
does it make it deuterium?
No. If you replace the electrons in a hydrogen molecule with muons, what happens to the molecule?
It gets heavier. It gets more massive.
Okay. And because it's heavier, what happens to it internally?
It collapses?
Yeah, somewhat. It gets smaller. That's what it was.
It becomes more dense?
Yeah, it contracts. Yeah.
Okay, I'll take it.
Yeah, it gets tighter, which is a possible. Scientists looked at that for cold fusion. They said if we replace the electrons in a hydrogen molecule with muons, then the nuclei will be closer together, so they'll be easier to fuse. So they'll fuse at lower temperatures. Okay, so I'm going to take chemistry for 800.
This man is taking chemistry for 8.
I am indeed.
Okay, sorry.
No problem.
You're familiar with the pH scale?
I am.
What is the and this is a range, so if you guess a number anywhere in this range, I'm giving it to you.
Okay.
What is the pH of a lemon?
Ooh, of a lemon.
Of the juice inside a lemon, more specifically.
Okay. It's acidic, which means... Shoot, I forgot. Low numbers means acidic. High numbers means basic. So I'm going to say 4 or 5. Yeah, let's go with 4.5. Bam, right in the middle.
0.5, final answer?
Yes, that is my final answer.
Incorrect.
Oh.
It is 2 to 2.6 pH.
What?
Yep, look it up.
Dude, isn't the pH of hydrochloric acid like, look, hydro...
Look up lemon juice. Look up the pH of lemon juice.
Okay, I'll look up lemon juice pH. Okay, let's see. Yeah, ranging between 2 and 3. But look, okay. Okay.
Hydrochloric
Fine.
acid.
It's 1 to 2.
Is 1 to 2, yes.
All right. You win. What? Okay.
I'm joking.
So, previously on the Lagrangian Standard Model, L, G, C, W plus, minus. Okay, now beginning the episode. M squared times W plus subscript mu times W minus subscript mu minus 1/2 times subscript nu times z0 subscript mu times subscript nu times z0 subscript mu minus 1 over 2 times c squared subscript w times m squared times z0 subscript mu times z0 subscript mu. And I don't know why you wouldn't just square that. Minus 1/2 times subscript mu times a subscript nu times subscript mu times a subscript mu minus I times g times c subscript w parenthesis subscript nu times z0 subscript mu parenthesis or times parenthesis w plus subscript mu times w minus subscript nu minus, and you'll have to find out in the next episode of the Lagrangian Standard Model.
Brought to you by our suffering.
Brought to you by our sponsors, China. So, which will you choose?
It's been my Moby Dick.
Mm-hmm.
It's been my Herculean task.
Mm-hmm.
It's been the one thing standing between me and
mm-hmm.
Let me kill this particle beast and let me take particles for one.
Nice. It is an end to the reign, the devastating reign of the particles. Let's see. Oh, I love this one. What is positronium?
Wait on.
What is positronium?
Say it again real quick.
What is positronium?
You cut out. What'd you say?
What is positronium?
Positronium.
Positronium. And no, it is not the element that Tony Stark made in his lab in Iron Man 2. Or 3, or whichever one.
Positronium. Let's break this down. It's gotta have positrons.
That is true. It does contain positrons.
It's got positrons.
By mass, it is 50% positrons.
So I just need to figure out what that other 50%.
Yep. You're halfway to the answer.
A combination of positrons
mm-hmm.
and muons.
Why muons?
Is that correct?
No. Why muons?
Damn it! Muons because, well, if they're not the right answer, I'm not going to keep going with this. Positrons and electrons.
Yes! Nice job. You get 1,000 points. Just because I don't want to go back to that equation.
I stabbed that particle beast. Yep. I teared out its heart with my teeth.
Now think about this, right? Positronium is one positron and one electron orbiting around each other. Because one's positive and one's negative, and they're of equal mass, so they just orbit around each other until they crash into each other and die. But in the moment, could you imagine that? Like, that's a pretty fun image.
That's crazy.
Yeah. So now, biology for 1,000.
You're going to kill this biology beast.
That is true. I'm going left to right at this point.
Okay. This is another range. If you guess any number within this range, I'll give it to you.
All right.
How many years ago did Homo sapiens evolve? Did the species before Homo sapiens evolve into Homo sapien? How many years ago was that?
200,000.
200,000?
Yes.
That is correct.
Yay. Cool. 1,000.
200,000 to 300,000 years ago.
Nice. Right on the edge there.
Right on the edge.
Right on the edge.
I Walk the Line.
I Walk the
Johnny
Line.
Cash.
Oh my god. So, what is your next topic?
This 800's looking at me weird. Let me step.
Yeah. Okay, so let me pull up Physics 800. So, pounds are to newtons as kilograms are to blank. What is the imperial system's unit of mass?
All right. You said, state it again.
Yeah, okay. So, pounds and newtons, right? They are both measures of force or weight.
Yes.
Pounds are in the imperial system, and newtons are in the metric system. Okay. Now, kilograms and some other thing are units of mass, and kilograms exist in the metric system. So, what is the imperial system's unit of mass? It's very niche because you said make it niche, and it's 800, but yeah, it's pretty obscure.
Do you think I have ever heard this before?
Well, based on this live stream, I'd say no. But before, I don't know. You could be one of those people that watched like all 50 of Matthew Santoro's top 10 weirdest blank videos.
Yeah, no, I did not do that.
You did not?
I did not.
I probably haven't seen all of them, but I've seen quite a few.
Okay.
Quite a few more than I'd like to say.
Newtons and pounds, kilograms, and horsepower.
No. No.
What is it?
It is a unit called slugs that is that is equivalent to to 32 pounds. So 32 pounds on Earth has a mass of 1 slug.
On to the equation.
Yeah. Well, what did you expect with the imperial system?
That's true.
We've got feet.
Yeah.
I mean, we've got the weirdest units. Feet, yards.
That's true. Okay.
Like, whose yard is only 3 feet long? That's what I have to ask. That's my question.
Okay, here we go.
So previously,
let's pick up where we left off.
The standard model, M, 0, A, W minus, subscript nu, minus, and on today's episode of the standard model with a guest speaker, we continue.
Oh my god. W plus sub nu. W minus sub mu end parentheses minus Z0 sub nu parentheses W plus sub dir sub nu W minus sub mu minus W mu W minus sub mu dir sub nu W plus sub mu end parentheses, we're halfway there, plus Z0 sub mu parentheses W plus sub nu dir sub nu W minus sub mu minus W minus sub nu dir sub nu W plus sub mu end parentheses minus to be continued question mark.
Continued question mark. I hope no. Let's see if we can get these all right from henceforth. Okay.
You're putting a lot of...
Yeah. Okay.
All right, Max.
Chemistry for 1,000.
Nothing but grands.
Nothing but
chemistry
grands.
For 1,000.
Yep. What is...
Name The first 3 radioactive elements on the table.
Okay, the first 3. We've
The
got
first 3 radioactive elements.
Okay, we've got technetium.
Mm-hmm.
We've got something, and then we've got bismuth. And now I gotta think of that something. It's number 61, am I correct?
Sorry, let me hop over to my... Yes.
Okay.
So you've got technetium, which is number 43.
And bismuth.
There is something at 60.
And bismuth is number 83. Or whatever. Something like that. Okay. Let's see. I just gotta go in order here. Right? Is bismuth correct, though? Because if not...
It is not correct.
Okay, wait. Is it polonium right after bismuth?
It is.
Okay. Can I still get the point if I get this 61?
You've given me so much help.
Okay.
Yes. If you name it, it's yours.
Okay. So 61. We just need a reference point. 55.
I'll give you.
No, I got it. 55 is cesium.
Okay.
So 56 is after cesium. And after cesium is barium, which is 56.
Yes.
And then 57 would be actinium. And then 58.
Are you sure about that?
Oh, no. It's lanthanum. It's lanthanum.
There you go.
Okay. It's lanthanum. And then, so after that, so we've got lanthanum. So it's 57. Then we've got 58. 50. So 58 would be right above second one. So then 59 would be above protactinium. So it's above that. So then 60 is above praseodymium. And then 61 is above uranium. So it's the guy above uranium, which is promethium.
Is that your final answer?
Yes.
I don't know how, but you used the wrong equation and got the correct answer.
Whatever. What goes.
It works. I'll take it. It is not the element above uranium. It is the element above Neptunium.
Oh.
But you still got the correct answer nonetheless. So that is 1,000 in your bank account.
Yay. If only. Well, yes only. We're gonna keep these scores.
Yes, we are.
We're gonna keep these graviton bucks, graviton pesos. We'll have to mint some currency, but we'll figure it out.
Okay.
So, what do you pick?
I'll take physics for 1,000.
Nice. Physics for 1K. All right. Okay. What is the second derivative of position?
What is the second derivative of position?
So think of a position over time.
Momentum.
No. Think of a position over time.
Not momentum.
Not momentum. So think of
momentum.
Think of a graph that is position over time. Okay. Are you imagining it? Okay.
I am.
So now the derivative of position over time will be the rate of change of position over time.
Yes.
So now the derivative of this position graph, in other words, the second derivative, is the rate of change of the rate of change of position over time.
Yes.
So if you have...
So it's not a number.
It is not a number, but it is a value that can...
It's a value.
It's a value... Well, it's a function. It's a function that changes over time. It could be constant, but, I mean, it's just any function, you know? So, yeah. That's what... Yeah.
Don't think I'm going to get this one.
Okay, here we go. So, we've got... It's the rate of change. It's the rate of change of the rate of change. What does that familiarize you with? What does that make you think of? The thing repeating twice.
Something repeating twice?
Yeah.
Like squaring it?
Yeah, like squaring it.
So, the rate of change squared?
Mm-hmm.
K squared?
Wait, what? What's K?
K is the rate of change. Right?
Well, it's velocity is the rate of change in position.
Oh.
Because we're talking about position.
Oh. So velocity squared?
Well, not velocity squared.
It's not velocity squared.
The rate of change
velocity,
of the rate of
yeah, change. Velocity over time squared.
Not squared. That's because velocity...
Just velocity over time.
Yeah.
Bam.
Bam. Okay. Sure.
You giving that one to me?
I will.
Okay. If you wouldn't have given, because there would have been no way for me to surpass you.
Yeah. Because velocity
so we
over
almost
time,
lost.
Velocity over time has a much simpler name, and that is acceleration.
Oh, yeah. Acceleration.
But it is technically correct. So, yeah. Okay. Now, particles for 1,000.
Okay. Okay. Mac, I need you to follow into the...
Okay.
So right now, I can see on the stream, even though there is a 30-second delay, that you are looking at your right?
My
That's
what?
all.
Sorry, I can't. You're cutting out.
Are you in?
I am in present.
Are you in present?
I am in present mode.
Okay. Stay on this slide.
Okay.
Do not move slides. I can go back and check.
Okay, I will not move slides. I will just keep presenting this slide. Okay.
Yes. You have wiggle room. How many lines are in the Lagrangian?
Oh no, how many lines are in the Lagrangian Standard Model?
You have a wiggle room of...
Sorry, you cut out. Wiggle room of what?
Of 2.
2? Oh, dang. Okay.
So 2 below or 2 above? How many lines are in the...
Okay, let's think.
You must not look.
Okay. When I went 8 up, that was like, I'd say 2/5 of the way up. So let's go with 20 lines. Wait.
Final answer?
I'm going to go with... No, it was more like 2/7 of the way up, yeah. So let's go with 28 lines.
28 lines. Is that your final?
Yes.
That is incorrect. There are 30.
32?
36.
Oh, okay. All right.
You hate.
All right.
Time to get yourself
back to China. Okay.
By reading.
Okay. Previously on the Lagrangian Standard Model, sub mu minus...
it's got to be my voice. It's got.
Oh, that's true. Okay, it's got to be your voice. Previously on the Lagrangian Standard Model.
W minus der sub mu or der sub mu. End parentheses.
That was a big highlight. There was a lot of end parentheses. Yeah. Okay, so minus I times G times S subscript W times parenthesis der subscript nu times A subscript mu times parenthesis W plus subscript mu times W minus subscript nu minus W plus subscript nu times W minus subscript mu, end parenthesis, minus A subscript nu times W plus subscript mu, der, subscript nu, W minus subscript mu minus W minus subscript mu times der subscript nu times W plus subscript mu, and parenthesis, plus A subscript mu times parenthesis W plus subscript nu times der subscript nu times W minus subscript mu minus to be continued.
Question mark.
Yeah.
All right.
What do you pick?
Astronomy.
Astronomy. Nice. Let me pull up my nice document. Astronomy. Okay. What is the word for the point directly above your head in the sky?
No, that's not my answer. That's not my answer.
I didn't even hear you because you cut out.
That's not my.
I didn't hear you because you cut out, so it's good. Sorry.
Whatever it wasn't my.
Okay, cool. So the point directly above you in the sky. What is it called?
I think we might have to call this a lot.
I
don't think I'll be getting this.
Okay. What is your answer?
My answer is W minus sub der sub nu
No.
W plus sub mu.
Okay.
Parentheses.
The answer.
What was the answer?
Is zenith.
Zenith.
Yeah. Okay.
Wow.
Previously on the Lagrangian.
Alright, so unless you answer every other question incorrectly, I have lost.
Oh. Okay.
Alright.
Previously,
it's a very close game though.
It is
only
a very
400.
close game. So previously on the whatever.
So I started reading it, but end parentheses minus 1/2 W plus sub mu, W minus sub mu, mu plus sub nu, mu minus sub nu, plus 1/2 G squared, W plus sub nu, W minus sub nu, W plus sub mu, W minus sub nu, plus G squared times C squared, G squared times C sub W squared, parentheses ZW sub mu, W plus sub mu, Z0 W minus sub minus.
Wow. That was a very exciting episode. Very action-packed, very fast-paced. Okay. I choose physics for 1,000.
Max.
Yes.
How fast? Actually, here, I'll give you a 200.
Okay.
200 up or 200 down?
Okay.
How fast do you have to slap a chicken in order to cook it?
No.
Yes.
I thought you were going to say speed of light. How fast is the speed of light? Dang it. Okay.
How fast do you have to slap a chicken in order to cook it?
13.
How fast must the slap be?
Yeah. 1,300 meters per second.
In miles per hour.
Miles per hour. I think it's also 1,300 miles per hour then.
1,300?
Yeah.
Your final answer?
Yes.
That is incorrect.
Dang it. What is
it? It is 3,725.95 miles per hour. Must the slap be going?
Alright, whatever. I've cooked it halfway then.
You got what?
I've cooked it halfway then.
Yeah, you cooked it halfway.
Still gonna get salmonella. Okay. Previously on the standard model. Which one are we on now? Okay.
We are on the one that
6,
starts
right? Yeah, okay. Say your previouslys.
Alright, previously on. W plus sub mu 1/2 g squared. C sub W squared minus.
Okay. It's so funny. Okay. Z0 subscript mu times Z0 subscript mu times W plus subscript nu times W minus subscript nu, and parenthesis, plus G squared times S subscript W squared times, open parenthesis, A subscript mu times W plus subscript mu times A subscript nu times W minus subscript nu minus A subscript mu times A subscript mu times W plus subscript nu times W minus subscript nu, end parenthesis, plus G squared times subscript W times C subscript W times, open parenthesis, A subscript mu times Z0 subscript nu times, open parenthesis, W plus subscript mu times W minus subscript nu minus, to be continued. I feel like I get
that
it
one
now.
left me on the edge of my seat.
Right? I don't know. I feel like just by reading this, I'm seeing some like symmetries. Like the pattern, I love this.
I'm starting to see the pattern.
He's speaking the language of the gods. Right? Don't you see the W plus subscript mu times W minus subscript nu, and then reversing W plus subscript nu. Whatever. Never mind.
This is the Minecraft enchantment book language.
Exactly. Okay, here we go. Last question.
I've been sweating about this question the entire string.
Okay, this is really
fun. You said
it
was going to get personal.
It is. So your astrology sign is Cancer. Yes. So
yes.
When it comes to a romantic relationship, what is the least compatible astrology sign with Cancer?
Sack of least compatible.
Yeah.
All right, let's talk about the signs that I know. Aquarius, Virgo, Pisces, Leo, Sagittarius, Taurus, Capricorn, Libra, Gemini, I can't think. I'm missing 3. So I gotta pray it's one is not one. I said Capricorn, right? Okay. So I gotta pray it's one of those 3. It's not one of those 3 that slipped my mind.
Okay, so which one do you think?
Oh, Pisces, if I didn't say that, but I might have said that.
So what do you think?
This is... I have a 1... Actually, well, yeah, wait, I wouldn't have to say Cancer, so I'm missing 2. Okay. I have a 1 in 11 chance. I don't know... I probably should. It's less than 0.1. I can tell you that. It's less 10% chance.
So what is your guess?
Well, I had a very good relationship, so I'm going to say it's not that one.
With a what? Sorry, you cut it
I had a very good relationship with a Taurus.
Ah, okay.
So it is not that one.
All right.
And even if that is the correct answer, I will live my life knowing that...
No, I will give you confidence. You eliminated Taurus. Taurus, I think, is actually one of the good ones, so...
Yes, it is.
Yeah.
Indeed, it is.
There's a lot of good ones, but there's only one really bad one, which is why I said bad one instead of good one. That's why I picked that question, you know.
I have a 1 in 10 chance.
Just think of someone you really don't like.
In the words of Harvey Dent,
Uh-huh.
I make my own luck.
Ah.
I'm going to say Libra.
Libra. That is not correct. Let's see.
What was it?
I think that's the second most, though, so I don't know how I feel. It's Aries.
Aries.
But I'm pretty sure Libra is like the second
I didn't
least compatible.
The only one I didn't say.
Mm-hmm.
Oh.
Are you gonna be okay?
The only one I couldn't remember.
Let's see. Libra is second. Libra.
The only one I couldn't remember. Oh, I didn't say Scorpio.
Here's the thing. Okay, I will say Libra is the second least compatible. So, and it depends on the source too. I think I'm gonna give you that one.
You're gonna give me it?
Yes. Because the whole joke reason why we have astrology in here is because it's kind of BS.
It is.
So Libra is like there's Aries and Libra, so I'm gonna give you that one.
Oh, thank you, sir.
We just got to make this a nail biter. That's the point. So it's all down to this question.
The astronomy.
It's all down to the astronomy question. Well, lay it on me.
What is the name of the fictional Eucamenopolis in the story written by Sebastian Molino? What is the name of the city?
Okay. It's like, starts with like the letter X, right? And it sounds like a Z though. It's like Zan something, like Xanth.
Absolutely not.
No? Okay.
Absolutely.
No? Okay. Guess I got that wrong.
No, that's not the real question. I thought that that would just be a very fitting end.
Yeah. Thank God that's not a real question. Wait, what is it? What is it?
Eltham.
Eltham.
E-L.
Dang it.
T-H.
I was thinking thumb. Like blank thumb.
W submute.
I was thinking Xantham.
Xantham. Okay.
I guess I was thinking of the company Anthem. Whatever. Eltham.
Okay.
Eltham. Yes.
The last question is.
Yes.
How many Earths could fit into the sun?
Oh no.
You have wiggle room of 0.1 million.
So 100,000? Okay. How many Earths can fit in the sun? Okay. Let's break this down. The Earth has a radius that is about 1/100th the radius of the sun. So.
Here, I'll tell you if you're right on that count.
Okay.
Earth radius is that much. So. Oh, why do you give me 1 in meters or kilometers and 1 in miles?
Yep. The eternal.
Hold on, mile, no, 2. Hold on. It's that much. Copy you. Okay, and then Earth is that much. Yes, you are right.
I am right.
The sun has a radius that 109.4
Okay.
times bigger.
Okay. So radius cubed is volume for
It's true.
for solids of the same shape for proportionalities. So that gives Earth a volume of 1 in this weird relative unit, and the Sun a volume of 109 cubed, so let's say 100 cubed, which is 1 million. So then it's going to be a bit more. So 1.1 million.
1.1 million.
Yes,
Is that your final answer?
it is.
I'm giving you more wiggle room.
Okay.
Because you are very close.
How close am I? What is
The
it?
correct answer is 1.3 million.
Ooh, okay.
But I'm going to give that to you.
Yay.
So
Thank
the
you.
winner of the showdown of the decade
Mm-hmm.
is Gravity Max.
Nice. I say we both...
With a balance of $10,800.
I say we both keep our Graviton bucks. What say you?
I say that's a good idea.
I say we steal it from the Jeopardy host. Let's go.
I concur.
Wait, who is the host?
Come here, Alex.
Yeah.
Let's break those Trebek knees.
Okay. I'm going to go and let me just go into Drive. And I can just, I don't know, copy and paste this somewhere. Let's make a, here, new slideshow. Blank slideshow. And it'll be called Winnings. I will share it with you.
Should we do one of these like every...
Yeah, we could do these quite a bit. I will share this with you. Actually, I cannot share it with you.
Yeah, don't do that on stream.
Yeah, that's what I was going to say. Because blah, blah.
Well,
so we get
Max,
it. We get it. Yeah.
While we're at it,
Mm-hmm.
would you feel like lending me, say, 200 Graviton bucks?
And why is that? What do you need it for?
I don't know. It's just that my balance would be at 10,600 and yours would be too.
Mm-hmm. You know what I say
So
to that?
do you feel like sparing?
I say death is a preferable alternative to communism. No. Okay. We're good. This is good. We're both $10,000 rich on Graviton bucks. So from now on, I think each guest, should we give them a nice $100 Graviton buck for coming on board, for coming on the show? They'll get 100 each from henceforth. So, if you want Graviton bucks, which are way more valuable than V-bucks or whatever it's called, then you should come on the show. Yeah. So yeah, Graviton bucks, that's fun. So I guess that's it, right? What else more is there to do? You still here?
Yeah, sorry. What were you saying?
I was saying each guest should get 100 Graviton bucks for coming on the show.
Yes, I concur.
Let's retroactively. So we'll go through the live streams, and whoever has been on the live stream X number of times, you get that many 100 Graviton bucks to use.
I like it.
To
and
spend.
Then we could even include them in this Jeopardy game.
Yeah, we could in the future. We'll make each final episode like this, maybe. I don't know. Or we'll just intersperse it, whatever. Let's not commit to things, because then people are like, you said you would do that. So you know what? I'm not saying I'm going to do anything. Bam. Take that. So, what now? Let's see.
I think that's it.
I think that's it, yeah. So this was the last episode of Season 1 of the Gravity Max live stream. Like, in the standard, we got 12 episodes. I think it was a pretty good season. What do you think?
I think it was.
Pretty successful first season.
We learned a lot
Yeah.
about everything.
Yeah, exactly. And our next season will be starting in 2 weeks. So we'll be right back up there. And we're going to have a bonus episode that isn't really part of any season because it isn't really science related, so it's just for fun. We're going to be playing Rento.
Rento, it's so good.
China.
It's so.
I really hope we get that card. Rento, the best game in existence. You guys will be glad to see it. You should totally download Rento or play the web version so you don't get a virus. So, I shouldn't malign Rento like this. Rento is a great game. I highly recommend Rento. So, let's see. What else? I think that's it. Yeah, this was a fun season. What do you think? So,
yeah.
How was...
I would say definitely the best season so far. But...
Yeah.
Oh wait, I think season 2 is going to be better.
Yeah, I think so as well. We finally got
We're
this
gonna
monster.
We're going to have music.
We're going to have music in the background, I suppose, if I can find or
for the next stream, I beg of you, do not put the Rento music in.
The Rento music's going in.
No, you can have it for like 2 minutes max, but then at the after the 2 minute mark, people lose their minds.
The Rento music is good. I mean,
no, it isn't. You've been brainwashed. You've listened to it for too long.
Listen. First of all, I don't know how to mute it, and without muting you,
mute the audio tab.
Second of all,
I'll show you how to do it later.
It doesn't complete the Rento experience without the Rento music in the background.
The Rento experience will make the entire audience go psycho.
It's such good music, though.
It's not!
For Rento,
it's really not.
If we're calling Rento good, then this music is good. Okay? That's what I mean. It's good.
I'll give you 3 minutes.
Fine. I'll cut off the music. It's so fitting, though. What if I made it very quiet in the background? Would that be acceptable?
I don't know. Is it royalty free?
Oh, that's true. Okay. I bet Rento...
Maybe you can only have 3 seconds.
Yeah. But doesn't Rento own Rento? Are we even allowed... You're allowed to play games. Yeah, I mean, people... People play through all of, Life is Strange or something. I mean, it's some games that have, a very set narrative, people just play all the way through it, and it's well, what am I going to do now? Right? So I just think that when you see Let's Plays like that, you're well, I understand for open world games that it's fair to play that.
Mm-hmm.
But then you kind of give it all away when you do a Let's Play of a very narrative based game. But Rento, I would say, is open world.
Mm-hmm.
So yeah, we'll play Rento next time. I think that's it. I'm gonna end the stream now. See you guys next week. And then see you guys the week after for season 2.
Thank you so much for watching, as usual.
Yep.
We hope you enjoyed, and we thank you for being loyal Gravitons through the first season.
Yep. Thank you, and goodbye.